Song for you, don't say a word, don't make a sound. It's life's creation. I make worms turn into butterflies, wake up and turn this world around in appreciation. He said I never left your side when you were lost, I followed right behind. Was your foundation. Now go sing it like a hummingbird, greatest anthem ever heard.
Good morning, ladies and gentlemen. Please be seated. We'd like to start.
Sing it like a hummingbird, the greatest anthem ever heard. Now sing together. We are the heroes of our time. But we're dancing with the demons in our minds. We are the heroes of our time. Dancing with the demons in our
The international space industry is in full growth, driven by new technological innovations and a massive influx of private investments. In the past decade, the space market has doubled its size, the number of space startups tripled, and the sky is the limit. The private sector is now setting the tone in a field once strictly defense and security related. This paradigm shift creates a major opportunity for the State of Israel. Despite being a small country with limited natural resources, Israel is already a significant industry force, and our know-how and expertise make us stand out among industry giants. As this revolution forges ahead, it's clear that this marks Israel's golden opportunity to lead the new, hottest, top-of-the-range tech field to come. By becoming the 8th country in the world to send a satellite into space, Israel has joined an exclusive group of countries to whom space is fully accessible. Years of investments by Israel's security establishment, along with the Ministry of Innovation, Science and Technology's 40-year-old very own space agency, have boosted Israel's space abilities, which makes for an excellent starting point. Our achievements are an ongoing testament to Israel's space savviness and prospects. The Israeli Space Agency has spearheaded multiple local and international projects in remote sensing, image processing, communications, space computing, orbit service, human space flight and health, planetary research, deep space missions, and even planetary defense. And that's just a glimpse. The Israeli space industry has showcased its proven abilities in multiple projects and endeavors, from the lower Earth orbit to the moon and beyond. Israel helps Earth and space become one through technology, science, innovation, and most of all, its people. The possibilities are out of this world. The journey is within our reach. Join the ride.
Good morning, everyone. And welcome to the second day of the 18th Ilan Ramon International Space Conference. I hope our opening video has got you in the mood for some more space talk. My name is Eyal Ben Zeev, and I will be moderating today. Yesterday, we heard some very interesting discussions, and I have no doubt that today will be just as enlightening. We have an exciting schedule ahead of us, featuring very interesting talks and panel in different fields of space science and technology. So let's get started. 20 years ago, I was a student of his. Today, he's Vice President of Ben-Gurion University of the Negev and a world-renowned remote sensing expert. Since July 2022, he is chairman of the Israel Space Agency. I'm proud to invite to the stage Professor Dan G. Blumberg.
Thank you, Eyal. At some point, I was the professor calling him. Now he is the one calling me. Good morning, welcome. Professor Avi Dom, Chief Scientist of the Ministry of Innovation, Science and Technology. I think you're in the room. At the moment, I'm blinded completely by the lights, but I think you're here, I saw you outside. I saw Amnon Harari, the former head of the Space Agency for the Ministry of Defense, heads of space agencies from abroad. Mr. Uri Aron, Brigadier General Uri Aron, is not in the room at the moment. He's at another event. So I apologize on his behalf. They're at the Tivel event. There are actually 4 events going on this morning in parallel. And especially welcome to all of you here in the room with us that are attending the second day of the Ramon Space Conference. A big welcome and applause to you all. Distinguished guests, honorables from Israel and from abroad. It's an honor to be with you here today, to be here with you this morning. For me, this is a special occasion. Only 6 months ago, I stepped into the role of chairman of the Israel Space Agency, and now I'm here talking on this stage to you all, taking part in one of the biggest moments for Israel's space community and the space ecosystem, the Ilan Ramon International Space Conference. I'm entering this role with a big sense of commitment, of responsibility, as I replace a giant, a true pioneer, and long-standing member of the space community and science community in Israel, Professor General Itzik Ben Yisrael, who served in this role as the chairman for the Space Agency for the last 17 years. This conference and the Israeli Space Week are very much part of the legacy he's leaving me. I intend to honor it, respect it, and to continue with this for the years to come. I don't think Itzik is in the room at the moment. I saw him yesterday. But in any case, thank you all for everything you've done for the space community in Israel and generally for the state of Israel. Itzik really contributed a lot to the science and defense of this nation. As you probably know by now, we're marking the 40th anniversary of the Israel Space Agency, which is not a small feat for a small country like ours. 40 years have marked giant strides in technology, communications, remote sensing. All of these have played a role in building this ecosystem, the space ecosystem in Israel. During the last 40 years, the Israel Space Agency made significant leaps and bounds in innovation and technology, growing from a simple regulatory body into a national policy-making agency which promotes cutting-edge research and development, breakthrough space educational projects, and prestigious international partnerships, supporting the nation and the country. In fact, as you heard in the movie just before me, Israel was the 8th country among the family of nations to gain full access to space, alongside great powers like the United States, Europe as a whole, China, and some large other powerful nations. As we enter a new era in space where private actors take a bigger part in the space economy, humanity is racing back to the moon, and access to space is growing within reach. The Israel Space Agency is adapting itself in many ways. It's engaging and promoting the Israeli space and high-tech ecosystem, joining and contributing to the Artemis Accords. I think we heard about that yesterday. and investing in new approaches to access space while trying to promote a local economic growth engine around space. Currently, the council which I head, the Space Council, supports the space agencies working diligently to approve a strategic plan for the next 5 years for Israel's space program, promoting basic science, economic growth, and education. The Israeli Space Week and the Ilan Ramon International Space Conference are a wonderful testimony to everything that has been done, and I think shows what we'll still be doing in the future with the international community and servicing mankind. As we enter our second day today of this conference, I'm thankful for all the people who have contributed to the success of this conference over the years: ministers, heads of agencies, heads of the ministry, director generals, industry leaders, all of you right here in this room, and I might mention also the Goldberg family sitting in the back that have supported this conference over the years. Thank you very much and have a wonderful day.
Thank you, Professor Bloomberg. You know, the theme of the conference is connecting Earth and space, and one way of doing that is, of course, with communications. And our next panel is exactly about that. How do we interlink terrestrial, airborne, space communication infrastructure into one network? Let's see what the experts have to say. Leading the panel will be my dear friend, Dr. Raz Yitzhaki, co-founder of and CTO of Beutelsat, one of the promising Israeli telecommunication satellite companies. The panelists which will be joining Dr. Yitzhaki are Mr. Chagai Katz, Chief Product and Marketing Officer at Gilat, Mr. Roy Sofer, Senior VP Engineering at AST Space Mobile, Mr. Nadav Nachshon, CEO and co-founder of Gorilla Link, and Mrs. Miri Keren, Business Development and Partnerships at Deutsche Telekom.
Hello. Good morning. Thank you for being here. Thank you, all the panelists. So I'm Raz. I'm the co-founder and CTO of NSLCom and Beutelsat. We're going to talk today about how we can interlink terrestrial, airborne, and space communication infrastructure in order to create a seamless experience for the end user. The structure of the panel will be, we'll have each of the panelists present himself and the company for about 3 minutes. And then we'll start and go through questions. As you can see, one of the panelists is not here. Roy Sofer had to go to the US, so I had to find a suitable replacement in the last moment. So what I did is, like most of the people on Earth, I turned to OpenAI. And I tried to see if I could get some answers from ChatGPT that could be reasonable enough to be a panelist. So first I asked OpenAI, what do you think about this panel subject? And this is the answer I got. The current telecommunication infrastructure is divided into 2 distinct segments, terrestrial and space-based. Terrestrial networks provide the majority of the world coverage, while space-based networks provide more specialized services, such as satellite television and global navigation. The challenge is to interlink these 2 distinct networks into one unified network, allowing for more seamless communication between them. So I thought, okay, this is a good start, but it's a bit too generic. So I asked it a second question, which is, from the end user perspective, what does the end user expect of this seamless telecommunication? And the answer was, the end user expects a reliable connection with high speed and low latency. They also expect to be able to access a wide range of services and applications such as satellite-based internet and remote sensing. Finally, the end user expects secure, reliable, and robust communication infrastructure that is easily accessible from anywhere in the world. So after getting these two answers, I said, okay, you're accepted. So we have a fourth panelist, ChatGPT. I will not quote its answers to all the questions, but there are some interesting insights there. So let's start with the panel itself. I'll start by presenting what we do, NSLCom and Beutelsat, and then we'll have Nadav, Keren, and Chagai present their companies. So, as I said, I'm the CTO of NSLCom and Beutelsat. Beutelsat is an offspring of NSLCom. NSLCom is a company that exists for almost 8 years. We've just launched our second satellite 2 weeks ago. This is a high throughput nano satellite, which is relying on a technology we've developed of expandable antennas. It opens an antenna in space, so a miniature nano satellite can broadcast up to 2 gigabit per second, as opposed to the same size of a satellite without our technology that can reach 5 or 10 megabits per second. So it's currently being tested and hopefully will be fully functional in the coming weeks. So the company started making these antennas, then we switched, or we moved into providing solutions, a full turnkey project like we're currently providing. And what we're currently aspiring to do is to go to the next level, which is becoming a satellite operator. And in order to explain how that will work, I would like to show you a short video. Please play the first one. Okay. So what you see here is a Falcon 9 launch. On each of the launches, we carry 2 orbits of satellites. We have a total of 12 orbits, 250 satellites total. What you see here is about 50 satellites that are being launched into 2 orbits. Each of these satellites will weigh around 150 kilograms. They're not nanosatellites anymore. And now you see the second orbit actually going into its designated slot. And once the satellite is in its orbit, it starts to open. First you see the solar panels. These are the expandable antennas that are used for inter-satellite link. And we have between 4 to 8 user links that are creating the communication towards ground. So by creating this 250 strong satellite constellation, we're able to connect any 2 points on ground without touching ground, because we have the inter-satellite link. So use cases will vary between many things that require secure and low latency communication. This was our gateway, and what you see here is basically cellular backhaul use case. You can see connectivity to mobility, such as airplanes, ships, and trains. The next use case is the ability to provide residential internet. This will require augmenting the constellation with more gateways, because there's a lot of capacity needed there, but the satellites are already equipped for that. We have the IoT applications, which requires either a store and forward or a real-time communication. So the constellation is coming up, will be operational in 2026. We already have 2 satellites that are currently being built, and I hope to talk to you later and see how we can cooperate. So thank you for that. Next, Nadav. Please, stage is yours.
They told me it's going to be a very low resolution, so I can see now this is the case. Okay, thank you everyone first for coming here. Such an early hour in the morning. Arriving to Tel Aviv at this time, unless you stayed in Tel Aviv, is very challenging. So thank you very much. In Gorilla Link, we are a startup company doing something actually very simple. We want to democratize satellite IoT. So basically, any user can now harness the power of satellites for the use case. And until now, it could be expensive and complicated. But we figure out that it can be much more simple than it is. And actually, our first use case was chicken coops, because sometimes you can have a problem with the ventilating system of the chicken coops, and we're in remote locations. So, who figured out that this would be the first use case of how we started democratizing the satellite IoT? So we created a platform that basically enable any sensor to communicate using satellites. We are basically, I can say now operating in every and each continent, right? So you can have use cases almost all over the world, and it's complex, and we're trying to make it simple and accessible to everyone. And I'm here all day if you would like to have a quick chat. Thank you so much.
Thank you, Nadav. Miri, please present yourself first.
Hi guys, good morning, and yeah, really appreciate everybody coming here, especially in the rainy times. So I'm here with a little bit of color, Deutsche Telekom, and I'm gonna shorten my pitch because like to adapt everything. So in case you don't know, Deutsche Telekom is a multinational telecommunication company headquartered in Germany, and we have a strong presence in Europe and as well as in the US. A bunch of figures to show how great we are. We serve 1 million customers worldwide, and in case some of you don't know, T-Mobile is also part of our family, and they're serving nationwide customers, and hoping with the SpaceX projects, we're gonna go a little bit beyond. And we have one mission. We won't stop until everybody's connected. Here is a few examples on how we do that. I'm not going to a lot of things, but basically, T-Mobile SpaceX partnership, the 6G project that we're aiming for, and of course, worldwide innovation. We make sure to be worldwide, scouting the right partners to qualify them and to bring meaningful technology and impact our business and added value to our customers. Recently, we also launched the T-Phone, which is 5G for every pocket. And this is a little bit slide of why we're in Israel. We all know why. Like Israel, great place, huge innovation. That's why we're here for the past 20 years, looking for the right partners, collaborating with the ecosystem. And basically our innovation focus areas are anything that we can do to drive connection to our clients, to our customers, whether in life, in commute, work, anything that we can do to make it better. And of course, stay in touch. I'm here through the day, happy to help and give you more details. And thank you so much for this stage.
Thank you, Miri. Chagai.
Hi, everybody. I'm Chagai Katz. I'm the Chief Product and Marketing Officer of Gilat. Gilat is operational in the field of satellite communication for more than about 35 years or so. Some things that maybe you don't know about Gilat, but if you take an airplane today around the world, so there is a 22% probability that your internet will be based on a Gilat system. If you are traveling in Japan or in the US, and you are remote, most of your cellular calls will be on Gilat equipment, doing cellular backhaul over satellite. This is the case also in the US as well. If there is an emergency situation in Japan, like an earthquake, or emergency situation in England, in the UK, then the emergency service network of both countries are based on Gilat. So instead of me going over all those nice facts, I want to run the latest movie on our latest next generation system that is providing satellite communication networking for the new space, including the NGSO. So let's run this one.
Introducing SkyEdge 4, delivering the promise of the Elastics era. From the world's innovation center, where leading technologies make a difference, Gilat has been revolutionizing the satellite communications industry, innovating for over 3 decades with groundbreaking technologies, delivering high-quality broadband communications, leading the world in 4G and 5G backhauling, and astonishing the IFC industry with unprecedented speeds. Gilat introduces SkyEdge 4, the leading ground segment for the Elastics era, creating harmony between ground and space. SkyEdge 4, with its innovative Elastics architecture, delivers the 4 dimensions required to meet evolving SATCOM needs. SkyEdge 4 supports multi-orbit satellite constellations and very high-throughput satellites, and provides seamless handover between orbits. SkyEdge 4's elastic architecture brings the agility and dynamic nature of the cloud to satellite communications, enabling demand-based network elasticity and dynamic scaling while providing outstanding compute density. Software-defined satellites are supported by SkyEdge 4, working in harmony, creating an elastic network that constantly adjusts to always be in sync with ever-changing conditions and service policies. Through SkyEdge 4's Elastics Total NMS and fully programmable architecture, ground space orchestration is performed in real time. SkyEdge 4 provides a unique Elastics access scheme that simultaneously supports any application with TDMA and Elastic SCPC, even in the most demanding situations. Gilat's Elastic Dense Coding Algorithm, XDC, enables speeds of gigabits per second and superior efficiency. SkyEdge 4 delivers the ultimate ground segment for multi-orbit constellations and very high-throughput satellites with unmatched CAPEX and OPEX efficiency. SkyEdge 4 is a giant leap in ground segment technology, leading the elastic era of satellite communications.
Thank you. So let's move to the second phase. Miri, I'd like to start with you and have you talk a little bit about Deutsche Telekom's vision for the era of seamless connectivity.
So I guess a simple answer would be to give the best connectivity, the seamless connectivity, reliable, secure to our clients, to our customers worldwide. And I think we're leading the way and trying to aim to that goal by investing in projects, in research, in development. But again, the best answer is to give the best connectivity to this connection and age through our projects and through all of these good things that our friends here are doing. So hopefully we're going to be the ground base for that connectivity.
Thank you. Chagai, can you comment on that?
Yeah, I think we had a lot of discussion on this one in our company, and we came to the conclusion that the most important thing, and I don't want to talk about technology, is about the right of people to be connected. And I'm talking about the fact that connectivity is providing new opportunities for living, for education, for health, and so forth. And I think that's where we see ourselves as enablers of the fact that many people around the world, they don't have such privilege today. And I think that when we see how they are enabled to get those services and to get these rights, that's where I see the main purpose of the ubiquitous connectivity everywhere, never mind where you are.
Thank you. So, Miri, Deutsche Telekom exists for more than 25 years. And as we all see, the market is changing very rapidly. How can a company survive and grow in a market that changes so quickly and still be one of the leading entities in this era of communication growth?
So I think the short answer would be innovation and adapting to market trends, strategies, anything that we can do to drive innovation into our product technology. We do that through innovation, obviously, whether it's the project to satellite connectivity. We have the Hubram incubator based in Berlin to work with startups and embracing new technology to give our clients whatever we can do. So Deutsche Telekom is constantly trying to improve and give new offerings to our clients, whether it's mobile phones that, like, we launched the T phone, the connectivity from satellite home, and also, you know, home internet and home devices. So I think for us, it's the main point to stay ahead of the curve in terms of technology and offering that we can give to our clients. And looks like we're doing a good job, so hopefully we'll continue that way, you know.
Thank you. Nadav, talking about the ecosystem, what parts of the satellite communication ecosystem are interesting for you?
So for us, as I said, the point is to make everything more accessible, but we are looking at the ground segment, and the ground can be very challenging. If you want to do something very low cost, it's not a good word, cost effective maybe, because sometimes Gilat can provide the best solution, but it might be expensive for some industry. So the part of making the ground segment more accessible can be challenging by using multiple type of technologies in the ground sector, connecting them to satellites, and also in the satellites phase using cost-effective constellations that can reach even the most the lowest price point available in the market.
Okay, thank you. Chagai, can you talk about the segment that you're interested in?
Yeah, I think what we do when we look at the ecosystem, we always try to be to understand where the focus in the ecosystem is going. Now, the ecosystem is changing, and what we see today is that the ecosystem is becoming an arena that the satellite operators, the kind of Intelsat, SES, etc., they are the owners of the satellites. They become the important player in the ecosystem, and therefore we are focusing on providing them what they need in this new era. This is a changing situation, a dynamic situation, and what they need today is different what they used to ask from us in the past, and we see ourselves as partners to the satellite operators.
Thank you. Miri, what parts of the ecosystems are interesting for you?
So is it obvious? I would say satellites, yeah. But no, more in terms of we're looking at anything that we can drive and make our business better, whether it's cybersecurity. Obviously, we need to secure our clients. IoT, anything that drives the IoT better and gives our clients. Even energy sensibility. I myself leading the topic of domain here, and we honestly looking for connectivity, 5G solutions, anything that a good telecommunication company needs to grow and to be better later on in the future. Hope it helps.
Thank you. So the next question is, how do you think the communication satellite industry will look like in 10 years? And how will this affect your company? So I'd like to read the ChatGPT answer for this. Well, it says, I believe that the communication satellite industry will continue to grow and evolve over the next 10 years. I believe that there will be an increased focus on small satellites as they are cheaper and easier to launch. Additionally, I believe that the development of new technologies such as 5G and 6G will result in faster connection speeds and more reliable communication. Finally, I believe that the proliferation of advanced satellite constellations such as Starlink will result in ever greater coverage and improved communication speeds. Okay, so Hagai, what do you have to say about the next 10 years?
Okay, I will try to be a little bit more sophisticated than ChatGPT. First, when I did my MBA, I was told that the guys that tell you what will happen in 10 years, they earn much less money than the guys that work on the floor in the stock exchange, that they have to make decisions in few seconds. So to understand what happened in 10 years is, you can say whatever you like, nobody will remember. But in any case, definitely, I think I see some things that are going to happen. First, I believe that many of us will do a lot of software rather than hardware. A lot of the telecommunication, the satellite systems will be embedded in the cloud, which today they are not, but they are going to be there. And therefore, I think that the satellite communication companies will change from more hardware-based to software-based. And the business model will change from selling equipment to recurring revenue and selling software that is going to be very sophisticated. So that's the direction I see. One more comment about the ChatGPT. The disruption that Elon Musk is doing is, of course, felt everywhere. But what is not, people are not talking about the cost of maintaining the constellation. He already spent about $10 billion on that. And his break-even point is like $10 billion or so, a little bit less, a year of revenue. And is still not there. So I think in the end of the day, it's not going to be only LEO. It's going to be a combination of LEO and GEO and MEO, and it's not going to be a single play. The market will be more divided between the three elements. Okay, thank you. Nadav, what do you think? What's going to happen in 10 years?
So, this is some great notes you said there. So, I have so much to say. I will be going to be a Star Wars, right? No, I'm joking. So, I was just looking at Virgin Galactic, and I visited their facility in New Mexico. It took them so much time to develop their airplane, and they're still developing it, right? So just thinking about what happened 10 years ago, I think that in 10 years in this industry, the changes are not going to be that dramatic, meaning there will be new technologies up there, but I think that 5G, of course, it's going to be a game changer, but it might take some time. So 10 years, not sure yet. Maybe things taking more time than we think, but definitely there are going to be a lot of new technologies in space that will allow us here on the ground to provide new solutions that we didn't even think that's possible, such as penetrating buildings from space, getting meaning not on the defense side, right? For civilian applications. So yeah, the apps market from space is going to be something very interesting in the next 10 years.
Thank you. We'll continue with you. So, as you all know, we're witnessing a global positive explosion of the satellite industry. I don't know how many of you know, but about half of the operating satellites today in space were launched in 2022. This is amazing, of course, and considering Starlink, it becomes more obvious, but still, this has never happened before. And I would like to ask you, Nadav, what are the changes in the global satellite industry that enabled the current development pace?
So, of course, it's so easy to launch a satellite now, right? If it's a small satellites, compared to what happened a few years ago, like instead of a few millions of dollars, a few hundreds of thousands of dollars. This is the first thing. And then you have countries that allow you to launch from their territory in a very excluding, okay, never mind, but countries that actually want you to launch from their territory, they're making regulation less complicated and the launch much less expensive. Yeah, so everything becoming more accessible to organizations and countries to access space. So this is the big change now. And then electronics, of course, become less expensive, more accessible. All of this transformation in the industry. Yeah, I think this is the main events.
Thank you. Chagai, would you like to add
yes,
to that?
I think there are many aspects to that, and Nadav touched some of them, but I will relate only to one. As you are facing now, the most important thing is the availability for funding the effort. And I think that's the big change that happened, is that today the sources of the funding, whether it's private funding by companies like SpaceX or Amazon, or VCs, is changing. There is a lot of money flowing into this area, and that in the past this was impossible to think about raising constellations with thousands and thousands of satellites, raising billions of dollars to raise it and to maintain it. And now, because of several reasons, this funding is available because there is more hope and trust that that will make a change. So I think that's the main reason why we see this change, the availability of funds.
Thank you. Miri, one of the interesting announcements that were made was the cooperation or collaboration between SpaceX and T-Mobile, which is a company owned by Deutsche Telekom. Can you elaborate on that, please?
As much as I can. So maybe some of you noticed there is a live announcement between Mike, T-Mobile CEO, and Elon Musk to do a technology partnership to basically to put a cell tower in space to get connected to people in remote areas where there's no cell towers, no connectivity. So obviously the use case, first of all, is emergency, but beyond that, we're hoping to give everybody the access to stable connection without using a satellite cell phones, and to get your connection from the satellite in your average T-phone or any other phone that you would choose. Hopefully this technology, will enable us to, again, bridge the gap between ground and space. And nevertheless, it's going to be very interesting, and, keep an eye on it.
Thank you. So, talking about the cooperation between the cellular world and satellite communication, I'd like to relate to how is 5G affecting the communication satellite industry? And Hagai, can you relate to this?
Okay, that's a very up-to-date topic. So few things about that really, because we don't have a lot of time. First, the difference between 4G and 5G is that 5G is taking some of the frequencies that we used to play with in the satellite industry. So we give them the frequencies, they give us money, and we put more satellites in space. The second thing is, the second thing is that the guys in the 5G, 3GPP, they have some plans to leverage the 5G technologies into the satellite networks. These plans may cause a big disruption in the satellite industry. I just give one example. We may use the same chipset that the handsets today are using, for example, the Snapdragon of Qualcomm, also for satellite communication, which is not the case now. Therefore, I think that a situation where 5G will be all-encompassing framework, including technology, can really give a very strong boost to the satellite industry, making it much more available to everybody.
Thank you. Nadav, would you like to relate to this? How is 5G affecting the satellite industry?
So if all the projection will go as planned, right, everything will be much less expensive, probably in the ground sector, using mass production chipsets, and maybe not only for the high-end devices, but also for the low-end. Having said that, if you know how cell towers work, they actually works as orchestration of towers. It's not a single tower that can serve. So when you switch between cell towers on the ground, there is a technology that allows you to switch between towers. And this technology must be in space as well. It's complicated, so it will take time. But when it happens, maybe also there will be newer technologies available. But it's very interesting because actually when T-Mobile and Elon Musk have a press conference, I mean, that's it. You don't need to do anything else. Everybody know about space and communication, and then iPhone and Global Star Corporation, and the fact that Apple will fund the next Global Star constellation is really amazing. Who would thought about it? So yeah, it's great news.
Thank you. So the next question is again a question that I wanted to see what ChatGPT has to say about. And the question is, what will be the next event that can accelerate this development even further? So the answer I got was that the next event that could accelerate the development of a global satellite industry is the launch of an advanced satellite constellation. And then it talks about satellite constellations such as Starlink. And I was a bit confused to get this answer. And then I discovered that the data set that OpenAI was trained off ends at the end of 21. So OpenAI does not know about what happened in 2022. So actually the answer that I got from OpenAI was a prophecy. And actually it materialized. Because as we see, as I said before, more than half of the operating satellites were launched in this year. So I'd like to ask Nadav, what do you think would be the next event that can accelerate this development even further?
in one word, there should maybe a huge IPO of someone maybe will accelerate all the space industry, because when there is an IPO of a huge corporation, then it reflects all the market. So yeah, and we'll see probably some other great things that happen in the space industry. But yeah, this is what I think the next.
Thank you. Hagai, can you discuss the requirements from the ground equipment in the area of multi-orbit and VHTS satellites?
Okay. First, just explanation. Not in the far past, we used only to use the Clark belt, the geostationary belt. This is a belt that is 36,000 kilometers from us. And the nice thing about this belt is that it is stationary compared to Earth. That means that the antenna is very simple. You just have to point to a point in the sky. You don't need to track. Then, in the last few years, we had the initiatives of the NGSO, which is non-geostationary, and suddenly everything changed. And the world change is important. The ground segments of today, they need to dance together with the satellite, which in the past they didn't have to do that. They have a dialogue with the satellite, where the satellite is telling them, now I'm changing my power, now I'm changing the location of my beams, now I'm changing my physical location. So it's all about in the past there was separation between the satellite and the ground segment. Now they become one. It is very similar to the team, like terrestrial and satellites become one, and it is true. It is it takes two for tango, and what is required is really a dialogue between the systems. It comes with protocols, it comes with the ability to change very rapidly in terms of in real time, and of course it comes with high capacity and new applications as well. But I think if I want to say one word, it is the capability to adapt and to dance together with the satellite.
Thank you. So ChatGPT gave me a list of what's needed. It said multi-frequency receivers, high-speed modems, high-speed tracking antennas, and advanced signal processing algorithms, and finally software-defined radio systems. What do you think about that, Hagai?
I think it's amazing. I think that it's a list. It's a partial list. But I think if you look at the list, it talks about adaptability, the way to adapt, to go to different frequencies, to track, and so forth. So this is a good answer, maybe better than mine.
Okay, so we have a few minutes for final remarks. One of you, do you want to say anything that I missed? If not, then thank you very much. And looking forward to the successful continuation of the day. Thank you.
Thank you very much to all the dear panelists. I see some young people in the crowd here. I'm really happy to see the Israeli Space Agency is doing a lot of work around education with young people, and hopefully one of you guys or girls one day will be standing on this stage and talking, or sitting in one of the panels. Anyway, yes. Anyway, we talked about communications between Earth and space, but what happens when somebody tries to block or jam your communications? So our next panel is just about that. Satellites and ground stations experience different cyber threats and face different challenges when trying to integrate cyber defense into space ecosystems. Let's try to understand what can and should be done in order to have cybersecurity from ground to orbit. To lead this discussion, I'm honored to call to the stage Mr. Niv David, lecturer and fellow at Tel Aviv University, focusing on cybersecurity of mission-critical and space systems. Former head of aviation and space cyber programs at a leading Israeli defense company. Are you here? Oh, hello. Joining Mr. David are our panelists, Mrs. Buffy Wajvoda. I hope I pronounced that correctly. I did. What she said. Global leader for aerospace and satellite solutions architecture at AWS Amazon. Mr. Eli Cohen, MTC Director and Defense Solutions Specialist at Microsoft Space and Spectrum. Mr. Matthew Erickson, Vice President of Solutions at Spider Oak, and Professor Ran Ginosar, Co-founder and President of Ramon Space.
Thank you, Eyal, and hi everyone. So happy to be here. And following Eyal, your comment about the young people, so a personal note, yesterday morning we had some amazing lectures here by amazing people, and I was sitting with my friend Chrissy from NASA and telling her, hey, you know, I'm not sure why I'm even allowed in this room, and nevertheless speaking on the same stage with these people. So Eitan, Melody, Inbal, all the Rakia folks, no dream beyond reach. That goes all the way. Thank you. Okay, hey guys. Very honored to be here and very honored to have this distinguished panel here. As you all know, the space industry is going through its fastest evolution so far. The revolution is mostly about the commercialization of space, at least in concept, but more importantly, it's about the technological modernization of space platform, maximizing operational effectiveness, creating business opportunities and values, while supporting national security and connectivity for all humanity, following up on the previous panel. Actually, all space platforms and operations are mission critical. They are sometimes even defined by law or common definition, or as national critical infrastructure, and potentially regulated accordingly by governments, by agencies, and so on and so forth. I believe it was Robert Cabana yesterday who said it, we are in a business that is unforgiving for mistakes. And if I may add, that's the thing about rocket science, that it is still rocket science, even if we do some cyber around it. Space operations and space technologies have now become a blend, or as Buffy calls it, a mold, of commercially available IT technologies, traditional space-certified hardware running proprietary software, and industry-unique hybrid modifications of hardware and software. In common terms, space operations now include IT, IoT, OT, ST, space technology, just invented it, which demonstrates many similarities to other technological domains, but with many unique characteristics and challenges, second to none. These include global Earth orbit, multi-operations, unified command and control for swarms, constellations, and so on. And I think the cybersecurity risks are quite obvious. Last comment before I start the question to the distinguished panel. We see that cloud, or let's say the modern technologies that are around it, is expanding everywhere. It is about the 5G and 6G, and following the previous panel, so the 3GPP standard actually defines 5G and space communications as something that are part of the same standards. It can be for commercial use, consumer, enterprise, telco, what we call the cloud RAN, radio access networks, and now space. So, in 2018, I think it was, 2018, Amazon actually announced a groundbreaking new offering, literally groundbreaking, of ground stations as a service. Microsoft and other companies as well followed with similar offerings, and now we have really a plethora of business around this domain. Then I believe, Buffy, in 2020, AWS launched the new business of AWS Aerospace and Satellite Solutions Division, currently headed by retired Major General Clint Crozier, right? And we actually, Buffy and I spoke a few days ago. We were at an event with the Ernst & Young and Earth and Beyond venture. And so Amazon also has some other space business, like the Kuiper project and Blue Origin, and so on and so forth. So I'd like to start with you, Buffy. What actually drives tech giants and global tech leaders, such as Amazon, AWS, to space?
Well, for Amazon, it's always day one. We've always been a company of innovation. We've always been a company with a long-term view. And I think we can all agree that space is definitely a long-term view. But it's also exactly where the industry and, quite frankly, where Earth is going.
Okay. And same question to you, Ali, as a representative of Microsoft doing the same.
So first of all, thank you very much for having me. I think that Satya Nadella, the CEO of Microsoft, said we need to empower every organization and person in the planet. So definitely we want to connect each part of the industries around. We want to make sure that every organization have the right communication. We're going to deep dive in this panel, how we enable it even to developers and SDK, so other stuff that's going to get into the site.
Okay. And Matt and Ran, since you both represent two very fascinating startups, but you're not backed up by the same funding and tech legacy such as AWS or Microsoft. I see, Ran, you have a lot to say about that. But we'll start with you, Matt. And by the way, thank you again for making all the way from DC to Tel Aviv for this. Why are startups, especially that are cyberspace startups, actually looking into this? What exactly is SpiderOak doing around this, and what is the business opportunities that you see in this domain?
Oh, thank you. And so the reason why we're here is, at SpiderOak, we have kind of a pessimistic view on a lot of traditional terrestrial cybersecurity. Like, the question is how can we keep people from clicking on bad links? Like, why have we developed systems where clicking on bad links causes problems? And you can re-image a PC on the ground. You can go to Best Buy, have Geek Squad take care of it. But if your satellite does the equivalent of clicking on a bad link, you've lost it. And at the same time, a lot of the space segment is very legacy, state-of-the-art 1995 grade architectures for security and cyber. And as many of you that I've talked to over the conference already have heard, I describe new space as a Rube Goldberg machine, where you have lots of different things working together in ways that nobody ever really thought ought to work. And so that needs to be secured, and we see that opportunity there to drive that forward across the solar system.
Thank you. So these satellites clinking on links, it reminds me of the very famous, I think the most famous cyberpunk book and movie, Blade Runner, or Do Android Dream of Electric Sheep? Do aliens click on malicious links? Maybe we can add a follow-up to that. Ran, please, the same question to you.
So for us, space is not a side business. We are doing just one thing, and that is computing for space. So we are the #1 victim of any cyber attacks and the target of cyber attacks. And we have been building computers for space for years and have been very successful in that, and have done next to nothing for cyber protection. So we are an easy victim, sorry. And we look up to you guys to help us out.
And thank you, Ran. And staying with you, so that's actually exactly the thing. So your company, the company you actually founded, Ramon Space, formerly known as Ramon Chips, not Ramon French fries. And and you do actually resilient hardware, which also evolved to be cyber secure. And so continuing with you, how does this security and resiliency are bound together in your vision of Ramon Space from the hardware and up?
So on the hardware side, space resiliency started in many places by duplicating or triplicating the hardware and doing the same thing multiple times. But that's not extremely efficient, so we find other ways, and we still need a lot of redundancy and so on. When we get to cybersecurity. Of course, the first suggestion we have always hear, okay, why don't you run the same thing multiple times and just check to make sure that there is no anomaly anywhere. And yeah, it may sound very good, but it's extremely inefficient. So it doesn't make sense to run everything 3 times and just check, or even 2 times, and just check for anomalies. So hardware is, that's one thing you can't really rely on. The other thing is there are many hardware tricks, and we use some for cybersecurity. However, when we launch computers into space, typically missions last anywhere from 5 years and upwards, sometimes 20 or 30 years. And most of what we understand is that if you try to protect yourself against cyber issues by doing something smart in hardware, you are outsmarted maybe 2 years down the line. So whatever hardware that we will develop, especially for cyber protection, I think will be irrelevant 2 or 3 years down into the mission. And what do we do in the rest of the other 20 years? So most of the protection has to be probably software. We do some hardware protection, all the standard things such as secure boot and encryption and more encryption and even more encryption. But that's almost the end of that, and beyond that, we depend on massive software and more software defensive cyber operations.
Thank you, Ran. So turning this question back to you, Buffy, as someone who represents a company who is doing all that, doing this software, though also relying on hardware and this integration. So how do you see, how do you see the need to integrate this, I would say, defense in depth, starting from the hardware up all the way to the cloud? And how do you secure something that you don't even know what's the basis of its security? So if you get some stuff from Ramon Space, you know it is, but since we're talking about commercialization of commercial off-the-shelf components for space, so you need to probably add the higher layers of security in the cloud and beyond. So what's your thoughts about that?
Yeah, absolutely. So first off, I want to reference the panel that we just heard. I totally believe that in the next 10 years, space and terrestrial are going to be absolutely connected. So when we think about using our mobile phones today, and the gentleman mentioned tower switching and all of that, us users on the ground aren't necessarily aware every time our mobile phone switches towers. To us, it's a seamless user experience. And I think space is going to be the same way for all of us users. What makes that different, though, is space has been very, very long thought of as sort of an air-gapped, a different sort of network that was protected because it was literally so far away. With space being more and more connected, it's going to be more and more vulnerable to the exact type of IP type attacks, the exact type of supply chain attacks that we see now on terrestrial networks. So it becomes more and more necessary to apply cyber-type defense to space. To the second part of your question, though, I don't think that anyone can ever be safe of cyber attacks. You're never going to be 100% secure. The idea is to be able to detect when something happens and be able to mitigate when something happens. So technology such as software-defined radios and computing at the edge is going to make that easier for space, because now we will be able to adapt satellites where in the past it might have been hardware locked for years and years.
Thank you. And Ellie, same question to you from the Microsoft perspective, or not only from the Microsoft perspective, but in general.
So first of all, I can say that we have very advanced projects around this cyber in the space, and what we can do in order to make sure all the attack vectors around the space are really covered. It means from the communication from the satellite to the ground, how we can transfer as an X-band all the data capturing to the ground station, how we can analyze if it's coming to the quantum encryption and other technologies that we can embrace and make sure the other scenarios for defense, for example, we can enable them. Okay, which is key part that enabling all this space area. Microsoft, which is, I would say here, it's one of the biggest cyber company. Okay, there is many others, but if we are taking in total from the endpoints to the cloud and other stuff, so we are trying to capture all these capabilities and making sure that we are again enabling all this innovation in the space. Again, of course, making sure even the developers, when they're developing the communication, we are doing it the right way. Okay, the supply chain from the code, deploying it to the ground station, and doing everything right.
So staying with you, Eli, actually having you mentioned that, so and maybe you can throw us a bone here or a tip. Of course, I think Microsoft today focuses its entire security portfolio around the Cloud Defender, right? Which is pretty good branding, I would say. So are we expected to see a Space Defender, a Planet Defender, something of that sort? Or more seriously, does Microsoft, with all the Azure Orbital and all that, actually look at the cybersecurity for the end user also from the cloud perspective, cloud and space perspective?
Right. So, great question. So we have Defender.
Trademark for me for the.
we have Defender for all. Identity, as you know, storage, everything. Currently we don't have a plan specifically for space, but we have for OT. So we acquired one of the companies, CyberX, which was specifically for OT, for electricity and other, I would say, critical missions infrastructure. So what I think right now is we're trying again, gathering all these capabilities. And I guess in the end of the way, when we are thinking about the big scenarios of the space, how we can enable them, it's definitely going to be part of the portfolio of the defenders. Yeah.
Thank you. And Matt, moving over to you with actually the same question, but sort of a similar question. So SpiderOak definitely identified some gap in the existing portfolio or existing requirements, and I believe you have a lot of defense work, which we will not discuss today, but also some civilian and commercial. So what can you add to this discussion? Like, where do you see the trends, like in 5 or maybe 7 years? Somebody said we cannot foresee 10 years, but 7 is okay. And where do we need to, add these special things that are not the traditional cybersecurity or not even the, let's say, the innovative, but what would be innovative in up to 5 or 7 years?
Yeah, that's a great question. And again, you're on a roll.
Thank you.
So right now, space is kind of like a very fancy IoT in a lot of its own ways. And sometimes it's not even that fancy, right? We're putting sensors in orbit, and we're talking to them when they fly over a ground station, and we're getting data, pulling it down, processing. That's not very different from I have sensors in a field, or I've got a smartwatch. Oh boy. Now, just chuck it.
I don't, by the way.
Yeah, I noticed. And we're space enabled. Like, a bunch of us here have smartwatches, and we're space enabled on our wrists. A lot of ATMs just use sat phone. So, as we're moving forward 5 to 7 years in the future, I think we're going to start seeing more autonomy in space. We're going to start seeing more space native systems. And what do I mean by space native? As where a ChatGPT on one satellite asks a ChatGPT on another satellite for an answer, and the original ChatGPT goes, "Oh, that was pretty interesting," and never touches ground. And so the gap that you see there is IoT is broken terrestrially. That's the thing. We have these very fixed structures, and it takes a company with the resources of Amazon or Microsoft to master a lot of traditional cyber defense in a way that is trustworthy. These guys both do amazing jobs at what they do, and I don't want to run my own server anymore. Do I want a 24/7 security center? No.
Of course not. You're in conferences all day.
Yeah, exactly. Well, I can't fix a patch server from right here. Probably be very boring for everyone. So you have these fixed structures with your satellites that are designed they just talk to ground, or maybe, for example, the BeetleSat, you have this fixed constellation. But what if the satellites are multi-vendor? What if you wanted to start building capabilities in orbit where you have multi-vendor, multinational coalitions, and you have You have these different capabilities coming online. What if you could virtualize that and drive that across orbit? And I think that's a lot where we're going to see 5 to 7 years. And the gaps are IoT doesn't work for that. You need security systems.
That's a great point.
That work for autonomous systems that are autonomous native and decentralized native. So, you know, when a low Earth orbit satellite goes careening over the Pacific Ocean without any ground stations, it can't ask Active Directory what to do for a security situation. It can't send, if it gets a new threat threat vector that it's detecting, it can't send that back down to ground for analysis. It needs to be able to make decisions on the literal fly and move forward with that intelligently.
Thank you, Matt. That was, I think, a perfect analysis. Speaking of ChatGPT, so Buffy and I were talking on Monday, as I mentioned, and I realized that probably you guys know that on the Artemis 1 mission, beyond all the fascinating things, and of course some of the Israeli tech that were discussed yesterday, they also had Alexa, the digital assistant, the Amazon digital assistant on board of the Artemis 1, which was extremely funny because I have an Alexa in my kitchen, really. So she kept informing me all the time what's going on, and then they had some test, some switching on and off the lights in the spaceship. Like, what? That's a complete waste of AI. But maybe I think, Buffy, you can take the notes from Matt and have this Alexa talk to ChatGPT or something. And Ran, same question to you, again, with a minor customization. So you were talking about the need, so, you know, hardware lasts longer than software, even commercial off-the-shelf, even with LEO satellites and so on and so forth. But still, I'm not a hardware engineer, so I always feel that hardware is something amazing. Dead serious. And software is, well, software. What do we need to add, following up on Matt's remarks? So this is not IoT, this is not OT, this is really space T, or something like that. I hope T-Mobile doesn't sue me for this T branding. So from your perspective, not only what Ramon Space or similar companies do today, but again, in 5-7 years, where do we need to evolve towards that? And again, I think we're trying to inspire some entrepreneurs here, some other companies to follow this path. So what do you think is still missing?
So you said about being a hardware engineer, and I'm not a cyber engineer, and I think cyber protection is amazing, right?
We make a great team.
Right. So I might, you know, this analysis is very good. From where we see space is evolving, it's not only autonomous, but we keep hearing interoperability, in a sense that whatever great defense mechanism we get for SpiderOaks or Azure or AWS, they have to work with each other. And I guess it's not new in space, it also has to be, to happen on the ground, and we do it every day. In space it's even much more so, because not only do we have different customers that require that, even the same customer typically requires different parts of space to be coming from different vendors and so on. Now, I don't understand how you can create standardization in cyber protection, and what happens. There's a war out there. Do everybody have the same weapons in what's going on? But this is a great challenge for the cyber protection or cyber defense or cyber offense industry, that space alone cannot really solve it. Space is much more vulnerable than other places because of the requirements for autonomy. And it has to autonomously detect, search and destroy whatever attacks it sees.
Yeah. And actually, Buffy, going back to you, so you refer to this air gap, or it's even vacuum gap, to be more accurate. But that's like really a two-sided sword, because on one hand, well, it's not really gapped anymore. On the other hand, just as Matt said, you cannot be always connected. You cannot always have the power of the cloud, so to speak. You need to have this automation, autonomy for mitigation, for killing viruses or whatever, malware, or dropping the attacks. How do you see this trend evolving? And again, like, what would you think are the gaps in technology or even in methodology for combating that kind of risks in the near future?
Absolutely. So I loved what Matt was saying about, the need and the drive for autonomy in space. I have a great example of that, and that's the JPL Mars rover. So, of course, communication between Earth and Mars takes a while, and you don't want to waste that time in space. And so Mars rover was actually programmed with AI/ML, so it would be able to kind of self-direct itself based on this soil sample, based on this picture, use the AI/ML to go to the next spot. So that's an actual example of how we're doing autonomous thought at the edge. And we're going to see more and more at the edge. And so that's why Amazon and AWS is looking to do more compute at the edge, more capability at the edge. Some examples of this is we put AWS snow cone on the International Space Station.
Wow.
Just to see what snow cone looks like in space. And we had an experiment last fall where we did actual edge computing on a satellite. So yeah, I think more and more...
That was groundbreaking as well.
We're going to see everyone push out towards the edge. And as we explore more and more into space, these become relay points so that we can go further and further and further.
Thank you. And honestly, I must say that actually, sitting here in this panel with all of you and having Amazon Ingenuity and Microsoft Ingenuity on the same stage, I think it's the first in the world, by the way. So you've seen it here first in Tel Aviv. And thank you, Buffy. And yes, I know definitely Amazon is doing some amazing experiments with edge computing in space, quantum computing, and all that sort of stuff. So life is going to be very exciting there. So Eli, following up with you, and maybe to summarize this specific subject, how can we assure space operations for commercial and international civil ventures or civil operations? And again, so how do we take all these different domains that are now somehow interconnected or molded? I really love the word that you used, Buffy. I'm stealing it from you. And molded together, which is like traditional IT, which is OT, which is IoT, which is cloud, which is Cloud Run, which is 3GPP, and is space. But at the end, there is somebody at the end. It can be some fishy AI or non-fishy AI. It can be ChatGPT. It can be a human. It can be an alien. It can be all of the above. So how do big tech look at that from a holistic perspective and end-to-end security, like when all this converges?
We have a few projects around cyberdomes. We call it in Microsoft Cyberdome. It's meaning we are looking at end-to-end, say, attack vectors. What it means from the communication, the storage, and we're immediately capturing some areas in the cloud from the space. How we can transfer all this data, and of course the ground station who is operating all these operations. So in all these Cyberdome operations, what we are trying to do is reducing or recognizing some anomalies. Okay, this is the first phase when we are seeing what are the patterns of each users, what they are doing, if it's the operation side, if it's the SOC side, and then after all this analytics that we are doing is try to make some actions. Okay, around how to mitigate some attack vector, reducing attack surface, how we can again encrypt the traffic between some channels between the orbit and the ground. If we're talking about penetrating some insights from the data. Okay, so Buffy before that mentioned that we're doing, they are doing an AI. So how we are running, for example, machine learning or AI modules in the edge or in the cloud. Of course, we want to stream all this data to the cloud. So all this end-to-end, what we are doing is making sure that we have the right patterns, we're recognizing them, and if there is any changes, if there is something then, for example, many in the middle doing something that shouldn't do, we're operating real time and mitigate this risk. Again, it's coming just from OT and IT, all the area from the network to the communication.
That sounds good, and still a long way to go, because discussing AI can also be malicious, and there's the whole concept, a very new concept of adversarial AI.
ChatGPT is doing good stuff.
I don't know. This is Raz's business. I'm not involved in these gadgets. Thank you, Eli. This is good to know. And Matt, moving over to you for a somewhat different question. And I know that SpiderOak, regardless of your technological ingenuity and your technological concept, you're all about like hybrid use and constellation and multiple use and all that, which is, I think, what we are all about here also in this conference. But I know SpiderOak is one of the founding members, by the way, I think also together with Microsoft and Amazon and Deloitte now, of the Space Isaac, the SISAC. For those of you in the audience who don't know, ISAC is the Information Sharing and Analysis Center. There are different ISACs for different industries, like the telco, the aviation, which is the A-ISAC, a financial F-ISAC, and so on and so forth. And recently, like a few years ago, a Space ISAC was established in the United States. I believe they're located at Colorado Springs, right, not far from the Space Force. And actually, we wanted to invite the Director General of the Space ISAC to Israel, but she couldn't make it. So Matt, how do you see such initiatives that are not technological per se, but are all about information sharing, collaboration, global collaboration even, relevant, significant to the safety and resiliency and security of the space operations?
That's a great question. So a lot of space industries, especially with the major powers, including Israel and the U.S. and the other major spacefaring powers, a lot of space industry comes out of military use of space originally, or the national space programs. And because of that, traditionally there's this culture of close hold. We don't talk about our problems. If we talk about our problems, somebody else is going to find out about our problems, exploit them, and then we're toast.
First rule of Fight Club. Yeah,
exactly. First, you don't talk about space problems, and second, you don't talk about space problems. Yeah. And so the Space ISAC is really a kind of a groundbreaking effort to try and start breaking that down and creating a community where the member organizations can share within themselves what's going on. As a case in point, typically within the United States, if there's a threat in orbit, and we're not just talking about cyber, we're talking about jamming, we're talking about possible physical threats in space, that goes through the Space Force, and that by the time they get through declassifying everything and processing the data and up, down, sideways, your bird might have deorbited already anyway, and you don't care. And so organizations like the Space ISAC allow the private sector to work on this itself, and if it's a completely private matter that does not involve the government, why include the government? Or have to rely on bureaucratic work up and down and sideways. So that's I think it's getting off the ground, kind of figuratively and kind of literally, but I think they're doing pretty good work to get that sharing and start that ball rolling to break down this culture of we don't talk about our problems to a culture of we share and we solve all of our problems together.
Thank you for that, Matt. And I believe, and last I spoke with Erin, the head of the Space ISAC, about it, Israel is actually not a participant yet in the Space ISAC, and I'm not familiar with any business or commercial entity which is. And I think, Professor Blumberg, this is for you, because I think Uri is not here. Yeah, I see you. That I think the Israeli Space Agency should definitely take part in this global initiative, and we can talk about it afterwards, I guess. And yes, Ran, please.
So, back to the earlier question. You're talking about edge computing, for example, on the Mars rover, because the communication takes so long. This is just the beginning. Let's elevate this from just edge to data center in major central cloud computing. And what we're doing now, we are going upwards from just doing small satellites and one satellite at a time and edge computing to very large data centers in space. and it has to do, it happens or the targets are 4 different layers. So the first layer, the nearest to Earth, is the new forming space stations, where they will definitely need very large data centers to the tune of at least 1,000 CPU cores and much more capabilities, and maybe multi-petabytes of storage and so on. And then the next level upwards is the gateway, the lunar gateway, which will have to do a lot of work for moon missions and so on. And again, there's nothing you can rely on Earth for that. And the next level that we hear and we are challenged with is lunar surface data centers, which will have to not only take care of life there, but also manage a lot of activities and all the operation, all the logistics, all the research, all the science, and so forth. Everything has to be locally managed and so on. Yeah. And of course, the last one is don't leave the rover alone. Let's put a colony on Mars. That'll take a few more years, but the whole idea is that you slowly develop and get that way. And so now it's very large data centers. And these data centers have to be, as we hear from customers, potential customers or planners or dreamers, they have to be multi-cloud, multi-tenant, and so on. And some of them are on-prem type of data centers that are completely owned and managed locally and independently from other data centers in space and from the ground. And all of this is a very easy target for a lot of cybersecurity. And we see a lot of cyber attacks and exponentially growing rate of cyber attacks on the ground, and there is no reason to think that space will be any different.
Yes.
So whenever we talk about, we understand all the technical, the hardware and the software issues of building data centers in space is very clear. What we don't have a clue about is, well, how will you fight this on Earth, let alone in space? And it has to be autonomous, and it has to live forever.
That is an absolutely amazing point you make here, Ran, and I know we discussed it before. And actually, that's also a great segue for the last topic of this panel, because this vision that you just presented us with is actually also about the dual use of space, and the dual use not like the military civilian or the governmental civilian, but the dual use like space and Earth, or Earth and beyond, or space and Earth and space becoming one. All the mottos of this amazing conference. So really, this, if we develop and we evolve to new technologies, to new defense methodologies, to new systems and strategies, as I believe was mentioned yesterday, this can be a lot of use, a lot of value also here on Earth, and not only for the space use. So I think that is an outstanding point. And really the last topic I want to touch about, we have few more minutes, is actually the business topic, and specifically the Israeli business topic. So Ran, since we're already with you, you as an Israeli entrepreneur with this fascinating Ramon Space startup, and here we see that everybody we're all on the good side, not the dark side. How do we cooperate, or what is required for the Israeli industry to be more successful, or to, let's say, fly high and up in this cyber for space business, or relevant technologies? It doesn't need to be cyber per se, it can be AI, it can be all advanced tech. What are the barriers that you see that we need to overcome?
So we have learned long time ago that the world is a village, and space cannot be conquered unless you collaborate very tightly with the rest of the world. And space, like Matt said, has started from defense and so on, but grew very fast into being first a dual use, and now more and more commercial. So there are, of course, also all sorts of regulatory barriers, not just about cyber or security or encryption, but also about everything that has to do with space. And these some of these barriers are slowly lifted or fade away. We still see a high barrier between what used to be called the Western Bloc and the Eastern Bloc. There's not much collaboration with China at the moment in space. But in spite of that, there's a lot of collaboration, even with China, on a research or theoretical parts of development for space. And as an industry, we are required to try to open doors and try to follow political and government regulations and guidelines, in a sense of, if you want to operate in spaces out there, but it starts from a country, right? So if we want to operate in the United States, we need to also be a U.S. entity. And if we want to operate in Europe, we have to have European entities and so on. So that's the way the entire world is doing it. And if you ask, oh, is AWS or Azure, are they US companies? No, they are global. And most of the activities, even for Israeli companies that operate in space, they have to have a global presence. And we have seen that in most Israeli companies that have done things in space. And I assume that the same holds for cyber operations. Sometimes when we talk to a customer in some country, and they would say, okay, we'll only buy cyber protection from a local company, but that starts to fade away, and at the same time, most cyber protection companies do become international, and so these kind of barriers are going away. Now, as far as I understand, the little I understand from the cyber industry in Israel, there's a lot of export of cyber technology, cyber protection technology from Israel to the rest of the world, and it can be extended to space, and it should be.
Thank you, Ron. And Matt, same question, you know, from the American perspective, I believe it's your first visit to Israel, probably not last, I hope. And you've been here, and I know you've saw the beauty of the beach and everything else, but also the beauty of technology, and maybe you even like the people. We definitely like you. But what do you think, really, from an American perspective, what you can say referring to that? Like, how can we maybe have more cooperation with US companies and so on? Mm-hmm. And then same question to you guys, please.
Yeah, and that's as an American, and this is Matt Erickson speaking right now. As an American, definitely see the value of better together with allies and partners. That's going to be the best way forward. And if we can solve differences as allies and partners, it's a lot better than solving differences as enemies with guns.
That's a bumper sticker.
Oh yeah, the very wordy bumper sticker. So you got a sharp eye for that. But getting back to as Spider Oak, we see our technology as enabling for that. As I'm sure we're all aware, U.S. export restrictions, the intersection of cyber and space is very tightly controlled. Yeah. But we see the use of modern software, getting away from government-certified little boxes being the embodiment of all security ever, to flexible software. Just go to the App Store, download your security, right? And we see that as the future of being able to connect securely without having to have a rack of government boxes with a platoon of Marines following around everywhere in the world to be able to communicate securely, because that's one of the foundations of cybersecurity, is to assume that the bad guys is trying to listen in, right? Assume that everything that's not you is compromised already. And so if we have software that enables that, like WhatsApp and Signal, we can do that we can already do that. I can chat with you on WhatsApp. Yeah. Why can't my satellite talk to you on WhatsApp for space?
Eli, your perspective, and then Buffy.
In terms of time, I'll make it short. I think that regulation and make it more simplified. I think that we have all the tools. I think that most of, like I just said, we need to make sure that all the militias and all the other, risks that we have currently in the IT, we can take care of them in the space. we have the right to own this, I make sure that it's going to be very fast.
And Buffy.
You know, yesterday they mentioned the African proverb, which is, if you want to go fast, go alone. If you want to go far, go together. And I think that's such an amazing proverb. And I do believe that this is a global challenge, which requires a global community. On the AWS side, we have over 100,000 partners in 150 countries, which we are really, really proud of. You know, we started out in America, but we are trying to make ourselves a global presence. And I also think the more that we do together, the more we will kind of converge on standardization. We didn't really get a chance to talk about it, but space has been very, very bespoke in the sense that one company has this standard, one company has this standard, one company uses this protocol, that protocol. But as we become more and more connected and as we use global partnerships, I think we're going to drive to standardization, which will also help.
Thank you very much for this insightful thoughts, and I think we can definitely talk till the evening, and we might continue that later, but unfortunately we need to give the stage to the next panel. Thank you so much for being here, for your insightful vision, for your vision in general, and thank you very much to the audience for being here despite the weather.
Thank you very much to all the dear panelists. We're going to take a break now, drink coffee, mingle, and let's meet back here at 11 for some more exciting talks.
song for you. Don't say a word, don't make a sound. It's life's creation. I make worms turn into butterflies, wake up and turn this world around in appreciation. He said, I've never left your side when you were lost. I'll follow right behind. Was your foundation. Now go singing like a hummingbird, greatest anthem ever heard. Now sing together. We are the heroes of our time. Heroes. But we're dancing with the demons in our minds. Heroes. We are the Now go sing it like a hummingbird, the greatest anthem ever heard. Now sing together. We are the heroes of our time. Heroes. But we're dancing with the demons in our minds. Heroes. We are the heroes of our time. Heroes. But we're dancing with the demons in our minds. Heroes. We are the heroes. We are the This is gonna be the best day of my life. My life. This is gonna be the best day of my life. My I howled at the moon with friends, and then the sun came crashing in. Whoa, oh, 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 oh. But all the possibilities, no limits, just epiphanies. Whoa, oh, 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 oh. I'm never gonna look back. Whoa, I'm never gonna give it up. No, just don't wake me now. This is gonna be the best day of my life. My life. This is gonna be the best day of my life. My I hear it calling outside my window. I feel it in my soul. The stars were burning so bright, the sun was out till midnight. I say we lose control. This is gonna be the best day of my life. My life. This is gonna be the best day of my life. My life. This is gonna be the best day of my life. Everything is looking up, everybody up now. This is gonna be the best day of my life. We are the heroes of our time. Heroes. But we're dancing with the demons in our minds. Heroes. We are the heroes of our time. Heroes. But we're dancing with the demons in our minds. Heroes. The crickets sing a song for you. Don't say a word, don't make a sound. It's life's creation. I make worms turn into butterflies, wake up and turn this world around. go singing like a hummingbird, greatest anthem ever heard. Now sing together. We are the heroes of our time, heroes. But we're dancing with the demons in our minds, heroes. We are the singing like a hummingbird, the greatest anthem ever heard. Now sing together. We are the heroes of our time, heroes. But we're dancing with the demons in our minds, heroes. We are the heroes of our time, heroes. Dancing with the demons in our minds, heroes. We are the heroes. We are the. This is gonna be the best day of my life. My life. This is gonna be the best day of my life. My I howled at the moon with friends, and then the sun came crashing in. Whoa, oh, 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 oh. But all the possibilities, no limits, just epiphanies. Whoa, oh, 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 oh. I'm never gonna look back. Whoa, I'm never gonna give it up. No, just don't wake me now. This is gonna be the best day of my life. My life. This is gonna be the best day of my life. My I hear it calling outside my window. I feel it in my soul. The stars were burning so bright, the sun was out till midnight. I say we lose control. This is gonna be the best day of my life. My life. This is gonna be the best day of my life. My life. This is gonna be the best day of my life. Everything is looking up, everybody up now. This is gonna be the best day of my life. We are the heroes of our time, heroes. But we're dancing with the demons in our minds, heroes. We are the heroes of our time, heroes. But we're dancing with the demons in our minds, heroes. The crickets sing a song for you. Don't say a word, don't make a sound. It's life's creation. I make worms turn into butterflies, wake up and turn this world around in appreciation. He said, I've never left your side when you were lost. I'll follow right behind. Was your foundation. Now go singing like a hummingbird, greatest anthem ever heard. Now sing together. We are the heroes of our time, heroes. this anthem ever heard. Now sing together. We are the heroes of our time. But we're dancing with the demons in our minds. We are the heroes of our time. But we're dancing with the demons in our minds. We are the heroes. We are the This is gonna be the best day of my life. This is gonna be the best day of my I howled at the moon with friends, and then the sun came crashing in. Whoa, oh, 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 oh. But all the possibilities, no limits, just epiphanies. Whoa, oh, 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 oh. I'm never gonna look back. Whoa, I'm never gonna give it up. No, just don't wake me now. This is gonna be the best day of my life. This is gonna be the best day of my life. I hear it calling outside my window. I feel it in my soul. The stars were burning so bright. The sun was out till midnight. I say we lose control. This is gonna be the best day of my life. This is gonna be the best day of my life. This is gonna be the best day of my life. Everything is looking up, everybody up now.
כן. כנס הקודם. Well, it's great to see you all back here. There's a known saying in our space industry that space is hard. And one of the reasons, of course, is, gravity that keeps us down here. So in this panel, we're going to address the steps needed to effectively launch and expand into space, including how launch priorities may evolve over time. I'd like to invite to the stage Ms. Kaylin Shabita, a founder and entrepreneur in resident at Union Labs Venture, to lead the panel. Thank you very much. Our panelists are welcome to join the stage as well. Mr. Aaron Pratt, CEO and founder of Tahiru. Are you with us? Hi, thank you. Mr. Rick Spalding from Mentech Advanced Systems International. Thank you. And Mrs. Elena Einhorn, Senior Business Development Manager from Exolaunch. Thank you very much. And Mr. Ophir Azriel, apparently. Where are you? Oh, Managing Director, Astrosphere Israel. Thank you very much.
Hello, everyone. My name is Kaylin Shabata, and I'm from Union Labs Venture, a deep tech investment fund out of Silicon Valley, where I focus on early-stage investments in space tech companies. As we saw from this panel and this conference, 2022 was a very exciting year for space, and particularly within the launch economy, we saw a record high of 180 launches, 44 more than the prior year. And with that, we now have over 8,000 satellites currently in orbit, over which a bit more than half are currently active. And as we look to the future of the space economy and exploration, it's important that we're really thinking critically about the practices that we put in place to be not only economically sustainable, but also terrestrially sustainable and sustainable in orbit. From a financial perspective, the space tech companies were not immune to the turbulent market. While in 2022, we saw about $47.4 billion invested in 496 unique space companies. This past year, in 2022, we had $20.1 billion invested in 370 companies. But with this tough market, we'll breed innovation, and we'll see the best players come to the top. The strongest leaders in space tech solutions really drive this next wave of the space economy. And so that brings us today, and while I'm very excited to speak to this panel, we have industry leaders and experts who are really defining the way that we can pave the path forward for a sustainable launch economy, both terrestrially and in orbit. So with that, we've already introduced the panel members, but I'd love for folks to just give a brief introduction on who they are and their backgrounds. So Aaron Pratt.
Hello, everyone. I want to start with thanking the organizers of the event and the people that joined. I think it's great to see how together we can strive to put Israel in the front line of the commercial space race. Now, I'll tell you about our company. Tehir is a small payload launching company. We are looking to launch anything that is 500 kilograms and down. The interest we have is in the future of space launch, and we're looking for high cadence launching. Together with it, we are going to be the first company to land an orbital rocket fully electrically. Together with that, we're building an airline system that will help us with gaining the ability to launch from multiple places on Earth and choose the inclination that we are interested in. Our goal is to provide a fast, affordable, and green access to space.
Exolaunch is the global service leader in launch services, integration, and deployment services. Up to date, we are a decade on the market, and we successfully deployed 269. You're a German company, that's why we need the precise numbers. 269 satellites with 18 missions and 12 vehicle services. We were founded as a startup, although at that time we didn't know that word, and we didn't know that we were a startup. It was founded like a typical, maybe American startup, not very typical for Germany, under the roof of Technical University of Berlin, Chair of Space Technologies. And the research-driven innovations brought our founders to the idea that there should be a service provider for easy launches with diverse vehicles. And that's how we started 10 years ago. And we continue today. And the last year showed, because it was one of the best years for the company, the most successful one. And it shows the rapid growth of the interest of our clients, the clients who are coming back to us from year to year. And we are very proud to represent the European scene of successful companies on the market.
Thank you. So I'm Ophir. I'm from the Israel office of Astroscale. Astroscale vision is the safe and sustainable development of space. So people ask, what? Today it's not safe and sustainable. We have this big conference. What is the problem? So today what we see is unsustainable reality. Spacecraft go up and they have their own resources. But when these resources are depleted, or if there is a problem, there is no way for outside intervention. Astroscale mission is to develop technologies and policies, technology and policy, to promote debris removal and on-orbit servicing to ensure that space remains sustainable. In practice, we work across orbits, both GEO and LEO, and we have programs for debris removal, for end-of-life servicing, and life extension. These are current programs which, when they are implemented and launched, they will be the basis for creating solutions to create a sustainable development environment for space.
Yes, I'm Rick Spalding. I'm with Mantech Advanced Systems International, and what we generally do focus on is, in order to get your high-tech technology into space, you design your rockets, you get your payloads ready, but there are a lot of environmental regulations and public concern on the ground before you even launch. So our role is to kind of look at those regulations and make sure that during the licensing process, whether it be from a country or the United States or internationally, that you comply with the various laws and regulations, and that we look at the impacts to the environment, such as air quality, impacts to the marine environment, marine mammals, that sort of thing, whether it be from noise, sonic booms, that sort of thing. So that's kind of the overall overriding focus that Mantech does, is we look at the environmental impacts on land and how the public perception of that is.
Great, thanks, Rick. So I wanted to start off by first talking about the changing customer profile and how you foresee the customer landscape changing and how your businesses are shifting over the next coming year and years to come. Starting with you, Aaron.
Thanks. Yeah, so I'll touch the point of view of the launching systems. If we look at what we have today, what we're seeing mostly after speaking with customers is a supply and demand issue. There are up and coming satellite companies that are developing and are looking to launch to orbit, and they need to wait in line, long wait times to get launched. So basically, time to orbit is a challenge. Along with that, their development time takes a long time. There is not a lot of standardization in the industry so far. And ultimately, it comes down to high burn rate for these companies. So in order to keep up with a satellite company, you'll need a lot more budget in order to keep going. And as a point of data, in the past 6 years, there are 10x more satellites that are being launched into orbit since 2016. So we're seeing a giant growth. And it's been discussed throughout this event. When we're looking to the future, as we're thinking, what will we as a launch company need to provide, we're seeing a few things. We believe that there will be streamlined manufacturing. Just like today, in order to purchase processing unit, all of us know NVIDIA, Intel, AMD. Same way, there would be companies who would be the top-notch manufacturers for satellites parts. So these parts would also be space-proven. And it means that overall R&D time to develop satellites would be shorter, which will in turn means there would be more launches required on a much, much faster turnaround time. So all of this in this current situation is tough in terms of launching, but the pendulum will swing in the next few years. There would be an extreme diversity of launch companies. The offer satellite companies would have would be amazing, and it would make them much more picky. So, in turn, this will encourage a real competition in the launch industry, and we're planning for it.
I truly believe that the customer profile will change slightly in the next years, and we have good reasons for this. First of all, there is service-based applications and more demand from the market. Secondly, the new introduction of big data and artificial intelligence in the industrial process of all companies will also change and invite new players to play the space games on the market. The next issue is, of course, that the geographical coverage will also a little bit and slightly change, and the situation in Europe in 2022 showed us that less space-based countries will become more space-oriented. The lower cost for launches and production of satellites and applications will also stimulate small countries to be equal players with big countries, and the same will also happen with the companies. The companies who never thought of being part of space community, like health company, food company, internet company, mining company, will, of course, like we also observe it right now, but it will be increased in the next years drastically. Another issue is, of course, the introduction of new technologies, which some of them we can't foresee. Some of them are completely innovative, and that's how we can even not think about this. Our company, Exolaunch, is really looking to the future, and that's why right now, already today, because like our motto is not tomorrow, not in a week, but today we started to develop a new system, OTV, called Reliant. With this system, we plan to enable more companies, big and small companies, to enter the space market by helping them to organize the space logistics. With the OTV product, we can also enable the companies to sustain economically their businesses in this, that they can repair or just like to smooth, to shift the satellite already deployed on the orbit, and of course to fight the space debris, which is of course a next issue. But I truly believe that the healthy competition can really help us to avoid the Star Wars.
Thanks. Yeah, and I want to build on that, what you said about the OTV. So what we see, or what we would like to see with respect to customer profile, is that spacecraft that go up would be more prepared for servicing. So today, a spacecraft goes up. Again, all its functions are built inside. Some functions double or triple for redundancy and reliability. What we would like to see is more reliance on outside intervention. So the customer itself would be leaner, simpler, cheaper, and would be able to use outside servicing for more and more functions, and making the missions more agile and more cost-effective, and have actual broader access to many more potential uses for satellites.
So I'd like to tear off of what Aaron said, in that the use of additional launch providers is going to be an important and very important avenue for the launch companies and for the customers that they use in terms of launching the payloads. Whether they be vertically launched or horizontally launched, it takes a long time to get the approvals to do those launches. And building a new spaceport takes even longer. So I think companies really have to plan ahead to look at how that will be affecting their launch parameters in terms of when they propose to actually get into space, and in terms of getting their investors online, that sort of thing. So I think it's important to look at using existing spaceports to the maximum extent possible, and then looking at other horizontal-based providers that provide a little bit more flexible and more, you can use an existing airport. So it's a little bit more flexible, a little bit more reliable, and it's faster to get up online.
Thanks. And I want to circle back to something that you were talking about, Ophir, around having customers have the opportunity to have more systems to integrate in. And wanted to see from your perspective, what type of kind of changes need to be promoted to allow that type of future kind of state that you're alluding to?
Okay, I will refer to two things. First of all, there needs to be solutions. So today someone plans a mission and uses what he has on hand. What we want to offer is a list of solutions which will be in orbit to allow anyone to plan a mission already to use servicing capabilities which the industry would provide. And once technologies and solutions are ready and in space, people will start to use them for their own missions, making their own mission, again, more agile and more cheap, and many more opportunities for missions in space. Another thing I would like to say is, of course, to refer to the risk that is existing and growing every year, the risk of congestion in orbit. And this is another change which needs to happen. And again, the focus is on providing a solution. So if today someone is doing a mission and they say, okay, what can I do? If the satellite fails, it fails and there is nothing to do. We want to provide solutions so that if there is economically feasible technology that can be applied, then we can come and say, okay, what is the policy and what are the incentives and so on.
So there's a lot of talk around kind of reducing this friction generally. I'd love to use that and shift gears and talk about regulation a little bit. Elena, specifically talking around regulations within this new space economy, and perhaps ways that you think that the European agencies could really lean in more or change what they're currently doing. Do you have any thoughts on that?
We are a European company and we are happy to stay in Europe, and we are willing to be in Europe but being a global leader. And we have a very good connection and support from the European Union and European Space Agency. Mostly on the panels, people, like when taking the microphone, then they, like from companies, starting criticizing the government bodies and public bodies. But probably I can say that European Union and ESA are doing quite a lot to support the space sector in general by supporting the companies and the organizations and research institutions, and having the agenda not like for 1 year but at least for 5, like with Horizon 2020 first and Horizon Europe, and supporting accelerating programs for incubators and for startups. But there is still a lot of work to be done, and that's probably first of all like the clear regulation for the policymakers. I would say also increased collaboration on the international level, that European countries and member countries will also include into the projects Israel, other countries, United States. That collaboration will also support the European space market for sure. Strong regulations, national policy. I would also, of course, recommend to reduce a little bit taxes for newcomers, the new space industry, so that the new companies will feel much better and not concentrated on just earning money, but can also support the research and development and innovations in their companies. And last but not least, of course, the cooperation on the national levels. I mean that the member states will also support the national coordinators, and of course, coming from the academia, I would also support and encourage the education. And I was really thrilled by the fact that at this Ilan Ramon conference, and it's very good example that 20 years ago in Israel there was like probably just like one university building satellites, and that was Technion. Today we have like 5 of them, and yesterday I had like a discussion with professor from Ariel University. It's a small teeny university, and they also produce satellites. And that's how I believe the European policy should also act, stimulate small entities, research institutions, and private initiatives to become equal players on the global market.
Thank you. And similarly, Rick has traveled around the world doing environmental overviews for securing launch licensing. And I'm curious to hear your thoughts on, is there a way to kind of standardize that process internationally, or just streamline it and provide better transparency so that we can hit the cadence of launches that we are anticipating to see in the future?
Oh yes, definitely. One of the things I've noticed in the various, especially European launches, is that even though there are MOUs, government-to-government MOUs regarding launch activities, these launches occur within one, say, area over the Atlantic Ocean, but yet the first stage debris or the fairings fall in another country's jurisdiction. And there's a lot of kind of uncoordination, I guess you might call it, between countries about what that will be when that will happen, what that means, what sort of laws, local laws and jurisdiction do they need to comply with, whether there be international treaties such as the London Protocol or MARPOL or OSPAR, those sorts of things. And I think there needs to be a lot more earlier coordination, because in my experience I found that by the time a launch license is, say, sort of communicated to, say, Portugal, they're now playing catch up and trying to define, what sort of marine license do we need? What about the NOTAMs and NOTMARs that need to be established in Irish airspace, Portuguese airspace, French airspace, if you have a north-south trajectory that you want to try to meet. So there needs to be a lot more sort of early coordination. And with that in mind, a lot of these launch operations are the same. It is rocket science, but it's not, because it's the same sort of items falling into the ocean. It's the same sort of sonic boom type effects. So a lot of this could be standardized and kind of, across jurisdictions, so that the process is much more efficient, both in terms of time and money, and therefore the licensing will come across faster. Launches will go much smoother, much quicker. You still have to involve the public in a lot of jurisdictions, and transparency in terms of how the various launches are set up and how they're licensed across jurisdictions.
So that's a great segue into talking about sustainability. First, speaking about terrestrially, you mentioned sonic booms, fairings falling into the ocean. Aaron, can you speak a little bit more about, just the general concerns that the public and governments have about environmental sustainability, and what your company is doing to kind of tackle that problem in a long-term way?
Yeah, definitely. I believe this is a very important topic. I think it's not being discussed enough. We see more talks about it, but if we're comparing space into the car industry for a moment, it took us 100 years to get to a point where we are looking into alternative power sources, electric cars. If we look at the space industry, as we fly up with Earth's massive gravity, we pollute a lot more. If I give a quick example, the 16 to 20 tons payload rockets, the big rockets that fly today, their launch takes about 8 minutes until we are in space. This period of 8 minutes is compared to a car that is driving for 200 years in 8 minutes. Now, we're speaking about colonizing the moon and Mars. That will require a lot of launches. And if we are not thinking about it, and if we are not going to make the change faster, if we'll make the change in 100 years, we'll not be here to talk about it, I assume. So Tehura is building the first thermoelectric rocket system. We're looking at multiple avenues, which we may talk about the rest of them later in this panel. If we're focusing on the sustainability part, first, we're an air launch system. Being on an airplane is basically leading us to reduce about a third of the size of the rocket, which means we burn a lot less fuel. The first few kilometers are the most fuel intensive during a launch. We reduce that. On top of it, we're also looking to land electrically, as I said earlier. The whole ballistic trajectory going back to Earth will be mostly use drag braking, so no fuel on board. And the final part would be electrical, which will give us the ability to land completely in a green manner. On top of it, we have some nice cool edge, like pinpoint accuracy landing. We can correct our trajectory if it's not exactly where we need to be. And finally, one more thing we're looking at is using net zero fuel. So this is a type of fuel that, while it's manufactured, it is taking from the atmosphere the same carbon dioxide, the same amount as we release when we burn this fuel. So if we'll successfully combine all of these variables in an economical way, we'll be able to show a launch system that is a lot less pollutive than what we see today.
And now I'd like to shift gears to same question, but when we talk about in orbit, how your company is thinking about space debris among any other concerns that you guys are addressing, and how you are tackling that.
Thanks. Yes, so the Astroscale specifically is focused on debris and debris removal. When we are looking at the risk for missions in space, today the risk is low, but the risk rises every year exponentially. We do not want to reach a point where the risk from congested orbits would start to affect missions, affect business models, affect funding. So this is something that must be mitigated. We see as a goal as 2030 a point where the tools and the solutions would be in place so that the problem of congestion at 2030 can start to be mitigated, and the curve of the risk, instead of rising, would start to fall. So the company is investing in programs right now, executing them, so that in 2030 we would have the tools in place that the industry would be able to start using and mitigating this problem, which unfortunately is not going away until it will be taken care of.
Rick, is there anything that you want to add on the environmental side of things, and any things in place to kind of ensure that we're taking a sustainable path towards launch?
Yeah, I think one of the big things that I've encountered during the actually surprising is that one of the main concerns due to the launch activities was the debris that's falling into the ocean, whether it's the first stage or the fairings, and what those materials were made out of. There's an cumulative effects of having all that go into the ocean, even though it's at, say, 4,500 meters in depth. It still has an effect on the environment. And if you're dropping things in here that are not, biologically, they're insensitive or they're hazardous materials, then you've got to kind of rethink your game plan. And I think more and more companies are looking at not having these hazards, like Aaron said, about having no fuel in his stage, even though he's recovering it. But if there's the fuels are more green, or they're, say, non-hydrazine containing, or they're just liquid oxygen, that sort of thing, then I think you're in much better shape. And if your components that you're dropping to the ocean are mostly say carbon fiber or stuff that's not going to be a biological concern to the marine environment, whether it be sessile marine animals on the ocean bottom or marine mammals, that sort of thing. I think a lot of companies are looking towards that, because there is a lot of concern from various countries about just essentially polluting the ocean over and over and over again. So I think a lot of companies are looking towards that, and that's kind of a good technological drive to get kind of a more greener, sustainable service.
Great. So you guys all represent kind of different parts of being able to enable the launch economy and the satellite economy. Kind of taking a step back further, how do you think that your respective industries can, once you've developed these technologies in a kind of flywheel way that you're referencing, what is the next step on leveraging the technologies that you have today to tackle the challenges around climate change and just generally the state of our current planet?
As a young and modern, innovative company, we set a big value on the climate change and environmental protection. And we are doing it in different ways, and it's not just like a strategy that is written on the paper. That's what we experience on a daily basis. First of all, we have an indirect way of supporting the environmental protection by providing launch services, integration, and deployment for payloads with Earth observation systems. So weather control, climate change, climate monitoring from universities, research institutions, private companies, space applications data. So that's our indirect way, but there is also like direct ways. First of all, our carbonic systems, our exopods, our products, and probably like those of you who could experience our suitcase yesterday and test the system separation carbonic systems themselves could also experience that all this was produced with the green industry. That's a very big issue for us. And the last but not least, the new system that we are developing in-house is just the OTV system that I already mentioned. But that should really help to protect our planet from space. Like that's exactly space and beyond, and cooperation of space on Earth. First of all, with green propulsion system, and secondly, of course, the OTV system will confront the main problem of space issue for the next 20 years, and that's space debris. We spoke with the panelists like before the panel regarding invading or conquering other planets. That's probably a very nice idea, but my point is always, guys, let's first try to protect our Mother Earth and then go to other planets.
I personally believe that we're at a point where pollution is continuous. We are continuously polluting, and it's very hard to stop once you start. It's like a person that is making a very high salary and all of a sudden it's cut in half. Very hard to change a lifestyle. So I think that apart from the things we've been saying here, green propulsion, reduce pollution overall in general from the space industry, one thing that is very important for me, for us as a company, is to be able to reduce pricing on a dramatic level to a point where we'll be able to support researches of universities. And I won't go into ideas I heard because they're really far-fetched, but if we work together and collaborate with universities, it's not full disclosure. It's not that we're only trying to support and provide everything they need. We're also thinking business and supporting universities at the beginning of a research that may be able to not reduce pollution, but maybe counteract the amount of heat that is getting to Earth. So by doing this, we can continue growing while we support the industry.
So I have a few more questions on my end, but before we close, I just wanted to see if there was any questions from the audience that the panelists would be happy to take. All right. If there is one, feel free to raise your hand, but we'll close off on, back to the main topic of the panel, which is the sustainable launch economy. So folks on the panel, just thinking from a business perspective, how do we make this work? I sit in venture, and it's very difficult right now to invest in launch companies, and Astroscale is a great example of unconventional funding practices to be able to really deliver an unconventional meaning. They had your founder was able to invest a lot of personal money into this dream of being able to save the planet from itself, essentially, right? But what are the other ways that we can think about sustainable launch economies and ensure that these next generations of ideas actually get into orbit?
I can start. I think that we should somewhat get to an agreement on the future of daily cadence launches worldwide. And I'd like to connect this with the internet, You know, if you think about the current status of the space industry, we can maybe equate it to the internet development to the ADSL era. Does people here remember the ADSL era?
Dial-up.
We were pumped up by 6 megabits per second getting to our house. If I would tell you back then that you'll be able to download the 4K video in minutes to your house, let alone stream it, you don't even need to think about downloading. No one would believe me in this room. So now I'm saying, let's all believe each other, and let's all watch the growth of 10x. We see more and more launches every year. So we should plan for it. And I think that when investors and governments are looking at it, the best players would be the ones that can very quickly launch to orbit. There are companies that say, launch companies that say, we can manufacture our rocket in 60 days. Some say we can manufacture our rockets in 2 weeks. Do the calculation. It's not going to work if we're not going to be reusable. So we're aiming for full reusability in the long run as much as we can, and we're aiming for daily cadence launch by 2029. That's what we're looking at, and our focus is on the area that has the most growth in this industry, which is small satellites, 500 kilometers and below.
I can formulate the strategy just in 2 points. First is reliable, reusable, cost-efficient launches from all over the world. And the second is from the policymakers and decision makers, legal, clear framework of cooperation.
This may not be necessarily green in the true sense of the word, but yesterday I was struck that there are a lot of rich companies are launching satellites and they're collecting the data, but that data is very expensive for other poor countries to access and to use to help their people and help terrestrial ecosystems, that sort of thing. So I think there needs to be a better business model where a rich country, a rich company, even though they have a business to run and they're looking at profits, that this data needs to be shared more equitably to other countries that need it more than, say, a rich country, because all the launches are coming from rich countries. And should a country like Zimbabwe be spending millions of dollars on launching their own satellite when they could be using a satellite from somebody else that is already, launching into space? There needs to be kind of a transfer of that data in a much more reliable way to other countries, and more sharing, I guess, is the word I'm trying to come up with. But so I think that's not really green, it's not really sustainable, but it is, because the public perception of the data and the use of the satellites is important. And I think be able to share that data in the worldwide, we're all connected sort of thing, and space is connecting us, I think is an important avenue to kind of look at.
I'll just say one thing, referring to what Aaron said. Many space companies, many launch companies. It might have been like a gloomy year in the markets, but still we see all these companies coming here to this conference, and looking forward, we see the space ecosystem growing very fast with many more missions. We urge to keep sustainability in mind, but still we see all these new applications coming online, and I think that the future is bright for this industry.
The future is very bright, and space connects us. Great points both there. Well, we're coming up at the end of the panel, and I just wanted to say thank you to everyone for joining us today, and to Aaron, Elena, Ophir, and Rick. This has been a great conversation. I very much encourage anyone here today to find them later on and ask them any questions that they have. They truly are the leading experts in their various areas, and so thank you very much.
נראה לי שמצטלמים. אופיר? הם מצטלמים. Thank you very much for the panelists. As you already understand, Israel is involved in diverse space projects, and the next one is no exception. The European Space Agency's JUICE mission to Jupiter is planned to launch in April 2023, and it will carry a measurement system developed in Israel. To tell us about the development challenges of this measurement system and the planning of the experiment that will use this system, I'm delighted to invite to the stage Dr. Eli Galanti, a scientist at the Weizmann Institute, and Mr. Roniman, a project manager at Acubit.
Right, thank you very much. Good morning, everybody. It's great to be here. Wait till the end and then you'll see if it's worth clapping. I'd like to tell you about a really exciting adventure that me and Ronnie are sharing, which is an adventure that started in Israel. We're designing and building a really unique instrument, designing an experiment that will reach all the way to Jupiter, and I hope will tell us a lot more about this great planet. This is a joint cooperation between us, the Weizmann Institutes, Acubit. We designed the experiment, and Acubit joined and built a really new design of an instrument that was never seen before, and all of that was funded substantially, a substantial funding from the Israeli Space Agency, without which we would never be able to do something like that. Okay, so a little bit of scientific background. Oh, I see that everything is together. Here's Jupiter on top left, is part of the giant planets, the 4 giant planets, Jupiter, Saturn, Uranus, and Neptune. And to scale, I put here also Earth, so you can see the relative sizes of Jupiter to Earth. You can put comfortably about 1,000 Earths inside Jupiter. Okay? Jupiter is a gas planet, but don't be fooled by the name gas. It's not a fluffy gas, maybe on the outside in the clouds that you see here, but inside it's a very dense and complex matter that get to about maybe 10 to 20,000 degrees of Celsius and pressures that are unbelievable high. Jupiter is really exciting, and starting from Voyager, I see, oh, we don't see the animation. Okay. All right. You'll have to imagine that Voyager at 1979 flew by Jupiter and showed us that those tribes that we see here on Jupiter high, they are moving really fast. There are very strong winds on Jupiter, very interesting dynamics that is organized in those stripes, east-west stripes. And this is the interest that we have in Jupiter. We study the dynamics in Jupiter, and we are already involved in a NASA mission, Juno, that is orbiting Jupiter for the past 6 years. We were able to discover, using Juno to gravity measurements, that those winds at the surface, they penetrate about 3,000 kilometers inside the planet. 3,000 kilometers. So very deep winds, very interesting dynamics. But we wanted to do more than that. And the thing that we want to get is really a 3D map of the atmosphere of Jupiter. Okay? Get the composition, the density, the temperature, the pressure at the outside of Jupiter, but get a 3D map, not just a single experiment. And the way to probe the Jupiter without sending a probe, which is impractical, is to do the following experiment. This is called radio occultation. You have the spacecraft transmitting a very stable frequency to Earth, and while it's outside of Jupiter, then we know what it should be. There is a Doppler shift of this frequency, because Earth is moving and the spacecraft is moving. But then there is this special time that the spacecraft starts to go beyond Jupiter with respect to Earth, where we watch it. Once that happens, then you have a breaking of this transmitted wave. You can see this in the lower line. And this breaking is as a result of the composition, temperature, pressure of the atmosphere. This is where our experiment is going to be. We're going to understand this breaking of the wave, and from that we get information about the structure of the atmosphere. But to do that, you need to have an ultra-stable oscillator. because the frequency has to be stable completely for about 1,000 seconds, 15 minutes. This is the time of the experiment until we lose the signal. And to do that, we need to really needed to build a new instrument, and this is where Accubit came into play. So Ronnie will tell you more about that. And our opportunity came with the JUICE mission. That's a European Space Agency mission to Jupiter. It's a big spacecraft. I'll tell you a little bit about it in a second. That will enable us to get about 130 occultation experiments with a very nice latitudinal and longitudinal spread. So we will get really, for the first time, a 3D map of the atmosphere of Jupiter. I won't go into the details, but doing that experiment will tell us more about the inside of Jupiter. And believe me, understanding Jupiter is understanding the solar system. This is the largest planet in the solar system. Understanding how it was created, how it evolved, will tell us also about our own Earth and how it was formed and evolved in time. So about the JUICE mission, it's European Space Agency mission. It was going to be launched. This is why it's very exciting for us. This April is the launch from French Guiana. And it will reach Jupiter at July 2031. Okay, imagine that. You need to be patient for a long time. And then it will orbit Jupiter and the satellites, big Galilean satellites of Jupiter for 4 years. In a few words, this is a huge spacecraft. It's about 5 tons heavy, okay? Really big one, powered by sonar panels. It has 10 instruments. On the left, you see all the instruments that do remote sensing, visible, infrared, ultraviolet, sub-millimeter radar for the moons. And on the right, you see other instruments, some particle instruments. There's the magnetometer, and then here's our instrument, the 3GM. This is a combination of 2 instruments. One of them is our ultra-stable oscillator. Our instrument will sit inside the vault of the spacecraft. It doesn't need to be outside because its functioning is to generate a very stable frequency that will be transmitted with the Huygens antenna, which is on the back of the spacecraft. A little bit about how you get to Jupiter. So it's a little different than sending a satellite to orbit Earth, right? Because when you want to go to Jupiter, you need to have a really high velocity to be able to get there in a reasonable time. And to do that, look at this orbit and that JUICE is going to do. It's going to be launched this April 2023. After 1 year, it will come back to Earth and do a lunar Earth orbit, get gravity assist from Earth. It will go away, get to Venus, get another gravity assist, like a slingshot, get back to Earth, 2026, go away, come back to Earth again for the third time in 2029. So in 2029, we'll get JUICE coming back to Earth, and only then it will go to Jupiter with the proper velocity that will enable it to get in a reasonable time to Jupiter. And then it will do an orbit of about, it will orbit Jupiter and the Galilean satellites for 4 years. This is when we will do our experiment. So I'll finish here and I'll get Ronnie continue with the development of the USO.
Thanks, Eli. Well, date is July 2013. Location is Rome University. Professor Luciano Yes is the PI, the principal investigator for the JUICE 3GM. He's calling Yochai Kaspi, Professor Yochai Kaspi from Weizmann Institute. Yochai, would you please call Accubit and check if they can make a USO for our project? Sounds good. Yeah? Okay. So Yochai Kaspi, he was not aware of Accubit, but he called Accubit in Jerusalem, and that was the story how we joined this project. Accubit is specialized in developing and manufacturing of accurate time and frequency systems and atomic clocks for space, military, commercial application, which combine high performance in a harsh environment conditions and advanced technology. Accubit is already doing that for 30 years almost. I think next year it will be 30 years. And we are in the communication, SIGINT, C4I, navigation, radar, spoofing detection, and space. Also, Accubit atomic clocks. Sorry. Accubit atomic clocks are actually part of the ground segment of the Galileo GNSS, the GPS, the European GPS, not in the space, in the ground. The first product in the space will be actually what I will just describe. So Eli talked about the spacecraft. Just take a look and see how does it look in compared to people on the ground. It's a huge one, and you can see on the right side, on the small side, you can see the ultra-stable oscillator located in the spacecraft. Okay, this is the ultra-stable oscillator, just some introduction. You can see the dimensions. The height is 10.5, and it's 16.5 by 12.5. Whoever went through our booth yesterday could see it and feel it. The main purpose of this instrument is to provide very stable frequency, as Eli explained, and the stability should be 5e to the minus 13, between 1 to 1,000 seconds, and under operational temperatures of minus 20 to 50 external temperature. It weighed less than 2 kilo. And the whole project was funded by the Israeli Space Agency. We are now at TRL 8. That means that we are ready for launch. This is the level of program readiness. We achieved the stability of 5e to the minus 13. I'll show you that in a minute at 1 to 1,000 seconds. We comply with JUICE environmental requirements. JUICE environmental requirements is very demanding. The magnetic field around Jupiter and Ganymede are crazy, are the highest in the planet that we know. So that means that we have to comply with higher radiation environment of the TID, total ionized dose, should be 50 kilorad. That's hard for the space components. So we made the qualification for this harsh environment. Here you can see we had to build in-house testing vacuum chamber, thermal vacuum chamber, that is very accurate, can control minus 20 to actually plus 70 C, because we had to test for minus 20 to plus 50 with a low pressure vacuum, at a vacuum pressure of minimum e to the minus 5, but we get lower than that. And the reason is that because the tests that we have to run every time are very long, and the stabilization go very slow, and it takes about 45 days for each test. So we had to have it at home, not mentioning that we need to have a very, very good reference in order to be able to test for this level of frequency stability. We had a management challenge here, and this was the first time that we worked with ESA from the beginning to the end of the project. A very, very tight work with ESA, with the Israeli Space Agency, and with the Italian Space Agency. They were all new for us. The Space Prime, Airbus Defense and Space also, were in very intense relations, so that's another demanding environment. And the Academy, Rome University and Weizmann Institute, so that was a challenge. Documentation, there is a joke running in ESA. If the weight of the spacecraft is 5 tons, then the documentation is 15 tons. And that's true, okay? At least our documentation. So that was very demanding. And COVID-19 started exactly when we started to build the flight model. And that was actually terrifying environment to work, but we were able to provide it on time when it was defined in order to start the test of the spacecraft itself. So I can show you a few tests that we ran on the USO. The testing was done in few sites. We can see here now tests that were done in the European Space Agency location in ESTEC. It's in Netherlands. You can see here magnetic sensitivity on the left, up left. In the bottom left, you can see microvibration. That means that it tests how the USO, ultra-stable oscillator, is behave under small vibrations when the solar wings are moving. On the right side, you can see in the bottom EMC testing. On the upper picture is performance testing. This is a vacuum tank, and you can see the USO inside. We performed tests in Accubit, and we performed the vibration and shock test in Rafael in Gusegev. We delivered 2 engineering models, 1 qualification model that we made qualification on, 1 flight model, it's PFM called, it's proto-flight model to those who are familiar with, and it was delivered on January 2021 and was integrated into the spacecraft at that time, and then flight spare almost a year later, and that's because of the COVID-19, most of this delay. Here you can see actually the results, and this is interesting to see because what you see here is on the x-axis you can see this is a time up to 10,000 seconds. On the y-axis you can see the stability, and as long as the numbers are low, it's better stability. Okay, and you can see the specification was 5e to the minus 13. And actually, on some of the range, we achieved 10 to the minus 14 results. And here below, we can see what Professor Caspi wrote, that in his opinion, this is the best stable USO in the world for deep space. And I got, by the way, the same comments from NASA, so I believe it now. So we are very proud of this. Here we can see...
Ronnie, let me just say, Ronnie is being modest. There's only one other company in the world that can do something like that. And the fact that a relatively small Israeli company was able to reach this kind of precision is really worldwide, will give them worldwide recognition. This is a really big achievement.
Thanks. Thank you. Actually, NASA contacted us for another mission. It's like a science fiction mission, and they're expert on. I'm saying that because Eli already talked about it. They're expert on time and frequency. Told me that if the results would not be signed by ESA, you wouldn't believe it because it's on the edge of the physical option at all. So here we are on the Twitter, ESA Twitter. You can see the team on the right upper picture, and they write that the 3 GM experiment with the state-of-the-art clock is now capable, complete and integrated into the spacecraft. And they thank Accubit and the 3 agencies and Rome University and Weizmann for their tireless dedication. It was really a crazy project. And here we can see another thanks we got from ESA. ESA and Airbus would like to thank Accubit, etc., for the results of the 2 USO units with excellent performance. The project was ended, but we wanted to use it for education for kids in Israel. And we announced on a picture competition up to age of 12. We got about 400 pictures, and we made a calendar. I don't know who of you visited us in the booth yesterday could get it. In the bottom of each month there is a question, and it's progressive. The questions are actually teaching you about time, clock, atomic clock, cyber, GPS, and quantum, and you have to scan the QR. You get this screen on your cellular, you choose the months, and you get the answer. It's including links for videos, etc. So thank you for listening. And now the only thing we need to do now is to launch JUICE. Please go ahead. I'll tell you something when you see the picture above, right? This picture actually, the idea of picture competition was not mine, it was ISA. They made it for the whole world, and that was about more than 2 years ago. And a Ukrainian girl, 8 years old, is the winner, and they paint her picture on the top of the rocket. By the way, the animation was done especially for this conference. I've asked them last week to do it, and they did it for us. The music, by the way, was added by my son. They didn't have enough time to put music in. I don't understand why they have to spend €1.5 million when they can do animation.
This is, by the way, the high-gain antenna that will deliver the USO signal. You cannot see the USO, as I said, because it's inside the vault. So it doesn't need to be outside. And the other thing that you will not see is how the sonar parlors are opening, but they are huge, huge panels on both sides.
85 square meter area. We wish a successful launch in April in Kourou. Thank you.
Thank you very much.
Thank you very much, Dr. Gallant and Mr. Mann, for this enlightening talk. Our last panel for today will discuss the stories of successful startup spin-offs in the space sector and dual application technologies that have use cases both in space and on Earth. We will also discuss the value that space technologies bring to humanity by commercializing them and applying them for Earth use. Alongside this, we will share interesting examples and stories from recent years. Leading the panel will be Mr. Raphael Roentgen. Are you with us? Mr. Raphael? Well, I'm guessing it'll be a bit hard to do the panel without him. So if anybody can try to find him, that would be great. Do you want to tell any good jokes?
In sign language, though.
Yeah, in sign language. I don't understand anyway, so I'm gonna laugh.
Some things that were said I didn't even understand.
Fair enough. So we're gonna wait another minute. Oh, here we go. Mr. Raphael, you can join us. And so Mr. Raphael is managing partner at E2MC Ventures. And with him, the distinguished panelists are Mr. Mike Colt, founder and managing partner of Promus Ventures, Mr. Victor Joseph T., director at the Directorate of Technology Development and Innovation, ISRO, Mr. Jonathan Gaifman, co-founder and CEO of Helios, Dr. Advocate Neta Palkovich, founder of New Space Firm, and Mr. Baruch Shchori, CEO of Earth and Beyond Ventures. Please take your seats.
Right, welcome to the spin-off panel. Spin-off is a very exciting topic, and I actually didn't realize, and some of you may have seen this and know that NASA, and of course we have many friends from NASA here at this conference, they very helpfully put out a spin-off report every year. You can find it on their website. I think it's literally just spinoff.nasa.gov. And the 2023 version of that spin-off report came out yesterday on the 31st January, making my life very easy, so I'm very grateful for that. And it's a 50-page report. It goes through many use cases of spin-off technologies. And again, spin-off, of course, is when we use research that has been done originally for, and technology that has been developed for use in space, and we bring it down to use it here on Earth. And so the report goes through many of these use cases, about 50 pages long. I highly recommend it. I'm just going to quote from the press release. NASA's spin-off 2023 features more than 40 companies using NASA technology, research, and funding to recreate better batteries, to store green energy, improve airport ground traffic, to save passengers and airlines time while cutting fuel costs, distribute ventilators around the world, and heal wounds faster on humans and animals alike. And then it goes on and on with use cases. And there's my favorite use case, quote is, NASA helps serve Yellowstone fungi, for breakfast. So there we go, many use cases for space technology, and we have a great panel to discuss that. Mixture of people from Space Agency, from VC investment. So let's go and introduce the panel. Why don't we start at this end with Mike? Just a couple of minutes introducing yourself.
Good morning, good afternoon. My name is Mike Colette. I'm managing partner of Promus Ventures. We are a 10-plus-year-old venture capital firm with offices in Chicago, San Francisco, and Luxembourg. We've invested in over 100 companies in about 30 different cities. We focus on deep tech, so that includes space, aerospace and defense, as well as robotics and a whole host of others. We are in a bunch of different industries as well. From a space side, we've been very fortunate to invest in companies like Rocket Lab, ICEYE, Spire, Mapbox, and a whole host of others. So it's great to be here.
Hello, good morning. I am Victor Joseph. I am from Indian Space Research Organization. It is a government space agency of India. We have our own operational fleet of satellites, including Earth observation, communication, navigation, and weather forecasting satellites, as well as capabilities for launching those satellites also. And with respect to the collaborations with Israel, we have a long-standing relationship. We have collaboration starting from 2002 onwards. We have launched satellites for Israel, Texar, and then we had collaboration on remote, microwave radar sensing satellites, and also we are currently planning to collaborate with more technologies with respect to electric propulsion systems, with respect to atomic clocks, etc. Thank you.
Hi everyone, Jonathan Geifman, CEO of Helios, an Israeli company. We are developing electrochemical and chemical reactors that refine minerals and ores to produce all sorts of materials like metals and oxygen. Our space use case is to produce oxygen on the lunar surface in order to reduce the cost associated with all operation in cislunar space in the coming years under the Artemis program, etc. And our spin-off terrestrial applications are using these same technologies to produce metals here on Earth for the metal industries in a way that is more efficient, energy-wise, and cost-wise. Thanks.
Hello, everybody. I'm Dr. Neta Palkovich. I'm the founder and CEO of the New Space Firm. which is a space law consultancy. I've been super fortunate to work with some exciting startups, whether they had spin-offs or not, in the space industry. And I'm very excited to contribute to this panel from the legal point of view and the regulatory point of view.
Hi everyone, I'm Baruch Shchori, the CEO of Earth and Beyond Ventures, and I'm very happy to be here. Earth and Beyond Ventures is a new Israeli venture capital firm. We invest in groundbreaking new space and deep tech startups aiming to solve the large challenges both here on Earth and deep in space. We are backed by great partners, both corporate and financial investors, including multinational deep tech leaders Corning and Kyocera and the Israeli Spacecom. And we are actively seeking cutting-edge technologies, companies, and research projects aiming to, again, to target the challenges both on Earth and in space in the main deep tech key sectors, such as semiconductors, new materials, smart sensors, new energy, quantum, AI, etc. We are also partnered with the Israeli government through the Israel Innovation Authority. And in addition to the business activities, we've set a business to generate and grow the Israeli deep tech and new space ecosystem. So we are partnering with all the different industry stakeholders, including government agencies, large technological and deep tech companies, aerospace companies, universities, and all the other stakeholders. So I'm very happy to be here, and hope you enjoy the panel.
Thank you, guys. I guess that just leaves myself. I'm not going to talk too much about myself, but I'm also a venture capitalist like Mike. I run a company called E2MC, which technically stands for Earth to Mars Ventures, sort of reflecting our ambition to finance everything that can get humanity to Mars. So we are purely dedicated space investors at the pre-seed and seed stage. Fund is based in the US, although I'm based in Europe. And we're very excited about spin-off use cases. In fact, we have about 20 investments to date. One of our portfolio companies, I'm going to give a shout out to, is a company in France called Interstellar Lab. And the vision of Interstellar Lab that the founder had was basically to produce vegetables and other plants grow them in space, in places like the moon or Mars. But then, and for that, they're developing basically fully autonomous, very advanced greenhouses. But then the founder, Barbara, realized that those greenhouses could also be used on Earth, especially in extreme environments like the desert, or to grow very high-value plants. And that's now, for the next few years, their main business, while the space part is developing. And as venture capitalists, I'm going to ask Mike about this in a minute, like we like it a lot, right? Because you have the space use case, but you can make money on Earth in the meantime. That's fantastic, because the space stuff sometimes takes money. And then the space stuff may kind of help you to win grants, government grants. So it's like the best of all worlds. But why don't we start talking about a specific use case? I mentioned the NASA examples and the fungi for breakfast, but let's talk about the metals, Jonathan, because you're the person on this panel who actually has a spin-off technology, or a dual use, not in the typical sense, but dual use terrestrial space. Why don't you talk a little bit about more what it is? And I also want to hear about your experience of taking a use case that started as a space use case and now trying to, I guess, convince terrestrial industry to adopt that.
Yeah, thanks. So just to give some more details on what we do first. So we started with the idea of being able to produce oxygen beyond Earth. Why? Because we realized that in the coming years, oxygen is going to be by far the most needed consumable. Not to breathe, I mean also for breathing, but it's going to be a very, very small part of it, but mostly to burn propellant. If we'll take as an example the human landing system that was chosen by NASA, the Starship, SpaceX's Starship, when fully loaded, this vehicle is going to be roughly 70% oxygen by mass. That's nearly 1,000 tons out of 1,400 tons, something like that. So being able to produce that oxygen beyond Earth can dramatically reduce costs associated with these activities. The most accessible oxygen beyond Earth is the lunar ground, the minerals on the ground, The professional term is regolith, which is basically minerals that have oxygen chemically bounded to metals. Now, the way humanity has been splitting these minerals here on Earth, mostly for the sake of the steel industry and other metal industry, is by using carbon, almost with no exclusion. And there is no carbon on the moon. So, and it will cost us above $1 million per kilogram to get it there, and we'll need to produce thousands of tons. So we had to figure out how we're going to produce this oxygen with no carbon. We came up with several ideas, did some proof of concepts a few years ago, and along the way we realized that, okay, we're producing oxygen, the byproducts are the metals that were bounded to that oxygen. So what if we are now applying these technologies here on Earth? Maybe we can produce metals and as a byproduct emit oxygen instead of carbon dioxide, which is what these industries emit. The first use case was iron. And immediately we realized that this technology, because it was developed under the harsh conditions of the lunar environment, is very efficient, also in comparison to how iron is produced today for steel. So we reached out to the industry, and I mean, today we're at a point where we're starting to work on pilot plants to produce iron for steel. And this is probably the major spin-off to that technology. When it comes to challenges on approaching the industry, I mean, in this specific niche case, the industry for them, they don't care about our space application. We have a better way to produce iron, so they're interested in this.
Yeah, but is there something more you can tell us about? So let's say you're going to like big established iron steel producers on Earth, right? And they may think you're like the crazy space guy, right? So how have these conversations gone? How were you able to, if you have been able to successfully, introduce your concept in what is a very established and probably to some extent conservative industry on Earth? I'm just using you because I suspect this is going to be a similar experience for whoever is having some spin-off industry. Yeah.
So first of all, I'll say that the space story is a great hook in the beginning of any conversation. Doesn't matter with who. But eventually, they look at the data, they look at the science, they look at the process, what we did, and if this is a process and we own the IP, and it's of interest to them, then we can bypass that. I mean, this is something that, at least from the steel industry perspective or other metal industries perspective, was less of a problem. The challenges comes more from the sponsors, from those who put the money on this, because then they're worried how we're going to manage dual-use projects, space, Earth, etc. And that's by itself is a challenge that we can elaborate on.
Let's ask one of the potential sponsors. So, Mike, if there's a space company and they have spin-off potential, how does that figure into your investment process? Is it like, so I was talking a little bit about my thinking and how it can be a good thing. Would you like share those thoughts, additional thoughts, or do you think it could also be a pain behind because now suddenly you have to think about not one target market but two target markets? How do you guys think about all of this?
Yeah, no, thanks. So we really, we don't distinguish between the two. All of our, well, I guess that's not entirely correct. We very much look at space companies as having terrestrial applications, right? So if you're going to build a moat with some type of cislunar application or some kind, you want that to have products that are to come down to space. So if you're a EO company like ICEYE, or you're selling ADS-B or AIS or GPSRO like Spire, these are applications and data that is helping out the Earth in ways that could not have happened, save the product being in space. We do have some companies. One is Lunar Outpost, which is a US-based company with an office in Europe as well, that is doing sort of cislunar transport. At the same time, they have an environmental tools business that is specifically targeted for people on Earth and is doing very well. So that is one instance in which there really are two businesses going on. And I don't know if we like or not like it. It is a little rare that we would see sort of two business units in a space company. But what we generally just look at, again, we don't really see ourselves as space investors. We see it more as a deep tech investor. And so when you marry all the different transformational technologies that come into this, you have applications that are, far wider than what you think. We are invested in a company called the Exploration Company, which actually just announced their Series A round today or yesterday. And there are many applications that are going to come out of that company which are going to be focused on just terrestrial. So whether I don't think we'll probably spin off of those things. I think generally you don't see companies truly spin off new companies outside of that, but you do see revenue streams that are going to be targeted in ways that none of us are smart enough to understand where all this goes. So things happen, and then all of a sudden this is an area within the company which is growing dramatically. So,
Baruch, I guess you guys also fall into the sponsor category that John mentioned. Any thoughts?
Thanks, Rafael. So actually, when we look at the spin-offs, we think it's a great opportunity both for the industry of Israel and also for us as investors, and I'll explain why. But our perspective is a bit different from the opposite direction. So we speak about spin-offs. We think of taking terrestrial technology and finding the right, appropriate use case for space, and I'll explain why. So three main reasons. The first reason is the deal flow. So we know that the Israeli new space ecosystem is still young in its early stages. We have a few dozens of startups, but we know that we have hundreds of companies in Israel developing deep tech solutions, sensors, smart materials, AI, cyber, etc. And then they do it for the automotive, climate, cyber, and other sectors. So if we want to have a significant deal flow, we now can look at hundreds of companies and basically partner with most of the Israeli high-tech. And we also find some strategic partners, large companies that have some shelf technology. So they promoted and pushed it until a certain point, and then due to the lack of resources, management attention, or the right partner, they just shelve it, and then we come and can define a new spin-off, a new use case for space. The second reason is that basically we reduce the risk. So many of these technologies are a bit later stage. They showed some proof of concept. Some of them are already validated and even commercialized. And then we can come and use the same core technology. But again, the new startup should still develop the additional layers of technology to enable the technology to operate in the extreme condition at space regarding temperature, radiation, etc. And the last and most important is that we harness the talent. So many of these companies, they have highly experienced and a relatively deep insight into the industry, how to develop the product, and then they are highly involved in creating these startups. So for us, we think that the spin-offs of existing terrestrial companies going into space is a great opportunity.
So funnily enough, just before somebody is going to criticize me at this panel for semantics, from the perspective of the space industry, that's actually, I think, technically called a spin-in, but that's fine. We can do the spin-off and spin. I'm just also sometimes when I teach at university, I test my students on this, and so I have to be accurate about it. But maybe you can use a concrete example, because your firm, Earth and Beyond, you sponsored a very nice event I had the pleasure to go to a couple of days ago on cybersecurity. And maybe you can just quickly talk a couple of minutes using that as an example, like taking cybersecurity to space and why that's important and how it's being done or how it could be done.
Great. So in general, we think that the Israeli high-tech sector is very good in component level innovation. So it was discussed earlier in this conference, but we think that the chances that an Israeli SpaceX is going to evolve are much lower than the new Mobileye, Waze, Innoviz, etc. And in this regard, we take the competitive advantages of the Israeli high-tech like cyber, AI, and what I mentioned like sensors, new materials, and we think that the connection between these verticals to the new space and new industry are amazing. So basically, this is taking all the building components of the Israeli high-tech and addressing or targeting the new space industry. Cyber is a great example. We see a lot of activity, and we are looking for the right opportunity, but we are sure that there is here in Israel the experience. The need is there, both in the aero and space industries, and we're really excited about it.
Thank you. So, Victor, ISRO. So I was talking about how NASA is thinking about spin-off, and they've been publishing this report for a long time. Can you tell us a little bit how ISRO, as another very long-standing, very prestigious space agency, is thinking about spin-offs and spin-ins, and some of the initiatives you're taking in this regard?
So, if you see the space technology, whether it is a launch vehicle technology or it is satellite technology, it is multidisciplinary. It involves multiple branches of whether it is science or engineering. So naturally, it will be connected to other technologies, and there will be spin-offs. Just for one example, if you see this, what we are trying to develop now is something which is called the left ventricle assist device. It is simply a heart pump which connects the left ventricle of the heart to the aorta. So it will be a partial saver for a nailing patient. So if you see the technology behind it, you have a pump, you have a mechanical device, a pump, you have coatings in that, you have the materials, the electronics, the software systems. So the technologies we develop for a propulsion system, if you see a turbo pump, the materials, the coatings, etc., are almost similar. So there is a direct relationship between the kind of technologies which you are using for space and other applications like medical equipment. That's what we are trying to say. Now, as far as ISRO is concerned, we have already transferred around 400 technologies to Indian industries, to around 600 Indian industries, mainly in the areas of energy systems, in chemicals, and materials. Then the COVID times, we have developed mechanical ventilators to be given to hospitals. And one thing what we have done is the space standard quality procedures. This kind of documentation, whether we can implement it in hospitals, that is what we have tried. And also software for analysis, structural analysis software. These are the kind of things which you have transferred from ISRO.
So let's expand on this a little bit further. So you have this just like NASA, you have this amazing, portfolio basically of technologies that can have very tangible use cases on Earth. But I think, coming back a little bit to what Jonathan was talking about as well, very often I guess the industries on Earth are not necessarily aware that they can use some particular space technology to benefit whatever they're doing on Earth. In practice, how is this connection being made? For example, is it education, is it events, or how does ISRO go about this?
We have our own outreach program, we have our own digital platforms which are available. We try to bring user meets with the industries and then try to showcase the technologies. There are also multiple cases where industries approach us whether this kind of technologies, whether it is viable, we can develop it through using our own kind of technology developments. So we have almost kind of established technology transfer mechanisms which we have put in place. And one thing what is important is what we are not, as a government agency, we are not trying to transfer the technology for kind of profit. We are trying to bring in industries, we are trying to promote, enable industries so that they can use those technologies and then try to develop it in a commercial manner.
But still, technology and knowledge, of course, is being transferred, and I guess in many cases, ISRO is technically the owner of the intellectual property. How does that work? Do you give a license, or? Yeah, the earlier cases, if we see the kind of MOUs we signed, we have put IP with ISRO. But then now what we are trying to do is we are trying to bring in kind of the announcement of opportunities kind of things where we will try to offer them technologies which are not in the full readiness levels, maybe in the TRL4, TRL5 or even less, and then allow them to further develop on it. And so that we will not try to hold the IP. They will be allowing them to further to hold the IP. So it's a kind of mechanisms we are trying to put in. Okay, because also again speaking as a venture capitalist, because this IP question and who owns it and exactly how this is being transferred strikes me as really important. I'm just going to ask my lawyer about this. So, Netta, what do you think? Considerations about IP transfer and spin-offs, and then maybe broader considerations that you think are relevant and important when we're talking about spin-off technologies or spin-in.
Excellent. Rafael, thank you very much for making the distinction between spin-offs and spin-ins. So, as we said, spin-off is really, Jonathan's mentioned, the case of Helios, just inventing something for space and finding a very, very good solution on Earth. And what Baruch mentioned is the other way around. And I have to say that as a lawyer and as a space law specialist, the spin-in case is far more exciting than the spin-off usually. because space law and everything that we do in outer space is right now far more chaotic and complex when it comes to regulations. And I think we have two different issues here. One of them is IP questions, which would come out anyhow, whether we do things on Earth or in space. But we also have this whole new regulatory layer when we talk about space law. And this is the exciting part, because some things that you surely can do on Earth, you cannot necessarily do in space. And if you think about Jonathan's example, extracting natural resources from the lunar environment, for instance, is not an obvious thing under international law. So in terms of IP and commercial considerations, there is no problem. There is a need for that. It's a super important thing which we would have to develop if we would want to be a lunar-faring species, let's say. But the fact is the United Nations is right now discussing the whole issue of how we're going to regulate exploitation of natural resources from the moon, which is supposed to be res communis, so something which belongs to everyone. And we have some a bit outdated treaties which govern this kind of situations, which still have the notion that whatever we do on the moon should be maybe to the benefit of mankind in its interiorly. And it's super interesting to see initiatives such as the Artemis Accords, for instance, coming out from the US, opening this and allowing the new space people to basically say, okay, we have what we have from the more traditional space regulation, but we must adapt it now to the reality of startups doing amazing things. On top of that, there is another layer of national laws, national space laws. So Israel still doesn't have a national space law. We are anticipating it greatly. But for instance, in the US or in Luxembourg came out national laws which explicitly allow companies like Helios to go to the moon and extract natural resources there. Of course, subject to international law and so on, but at least they made the effort to see it's viable. And I think for people like Mike and Baruch, these are super interesting things because they're going to invest in something like that. They should know what the exposure is and if there are any big regulatory challenges that maybe on Earth are not foreseen.
So I guess, if I understand this correctly and intuitively, it would make sense that if you're spinning in, it's probably more of a challenge because you're probably going from what is a very established regulatory and legal framework on Earth to, like we just say, pretty much law of uncertainty these days. But if you go the other way, if it's a spin-off, besides the IP, is there any other challenges on the legal side you think that you want to highlight?
Yes, of course. There's always a challenge somewhere, right? So let me give you an example of one of my clients. Is called Dawn Aerospace. And they started with an excellent product, green propulsion, I should say, for small satellites. It's going well, it's selling well, everything is great. That is a really classic space thing. And in parallel, because they have all this expertise in propulsion, they're also developing a space plane based on that. So it's not a classic spin-off, but they are kind of switching from pure space industry to aerospace, I would say. And now I have to regulate that new creature, that space plane, and it's the same technology. The IP is very similar. There are no issues there, but the scope of the activity is very different. So right now we have to talk to airports and see how we're going to certify that vehicle, which again, in outer space, there's absolutely no problem. You hook it to a satellite, it propels the satellite, everything is good. You don't have to go through, any regional or international authorities to certify it. So things as such, I would say it really depends. You start at space, but it really depends on what other industry you're going to spin off to. if it's a medical device, for instance, right?
Yep.
As Victor mentioned, that's super important to know. I started before I went to space, so to say. I started as a commercial lawyer, and I handled a lot of biotech companies, also medical devices. So there are clinical trials agreements and all these, right? All these Helsinki things, and there are so many specific practices you should be familiar with in order it to be a real success, I would say.
So it's funny, it's basically you are starting to operate in space like Dawn, you have this nice laissez-faire environment because of the lack of regulations, and then suddenly you have to deal with a bunch of regulators on Earth. Is that something at Israel, when you support spin-off activity, do you get involved in like trying to help the startups think about this? Yeah, sort of mentoring, hand-holding, helping them with, you know, the additional regulatory aspects.
Yeah, whenever we transfer the technology, we have an MOU with the concerned startups or the industry. Then we write down the kind of hand-holding. We allow them to come to ISRO, do the testing, and get the knowledge expertise with. And we have that is going on. That is there in ISRO. Yeah.
Jonathan, did you have to learn any regulations of steel industry or anything like that?
Yeah, so when we decided that we're going to spin off to steel and other metals, I mean, originally we thought, okay, it's great, so we don't need to worry about space regulation or lack of. But now, under current geopolitical situation in the world, more and more countries are considering critical metals and even steel to be under national security umbrella kind of industry, and suddenly we're finding ourselves in the same kind of issue. So it doesn't mean that we're, it's not that we're blocked to operate and stuff like that, but it just means that we need to first of all pick, who we're playing with very carefully, and do this in a way that will enable us as more options in the future. Because, and by the way, it's not only with who are our customers, but also who are our sponsors, investors. When we got into instance working with mining companies, suddenly we came to a situation where we need to list the LPs of our VCs to make sure that none of them fall under the wrong country, for example. So these are part of the situation that the world is now at, and we need to navigate.
So I was also curious, because I mean all of this is basically additional work, right? And so I was also curious from an organizational and like an org chart point of view, how you're doing this in practice. Like, for example, you're the overall CEO of the company. Do you have like one guy, one person who is basically taking care of all the terrestrial mining stuff and then a separate person for space, or how are you like organizationally solving this?
Yeah, so we are, on the R&D side, we have a different group that is working on the terrestrial side and is working with the steel makers to do the pilot plants. We have a team that works on our lunar mission to demonstrate the technology. We have an innovation team that works on additional applications, because this is something we learn again and again, that from working or developing technologies under these unique conditions, the extreme conditions, we just, these new applications just pop all the time, and they're worth exploring. How we're going to, entity-wise, how this is going to be structured, we'll see. So whether we're going to have subsidiaries or joint venture in different countries, it's going to be very on a case-by-case issue. Depends on the specific geography, specific government requirements, etc.
Okay. I have some more questions to ask you guys, but I wanted to see if there are, at this point, any audience questions. In which case you are happy to pose them. Actually, I can't see a thing because of the lights, but maybe somebody can help me. No. Okay, then I wanted to ask you, if we think about sort of over the next few years, there's obviously a lot of exciting things going on in the space sector. There's a lot of money being poured now into the space sector, both by governments as well as private investors like Mike and myself. What do you think could be some of the exciting spin-off stories we may see over the next few years? We start with Mike, because he's probably thinking about this by profession.
Well, I think, again, if you're asking spin-off stories in terms of new companies that are coming out of other sort of companies, you know, I think one thing that was interesting, I mean, space is so incredibly global and very complex, and it's only getting more complex. And so you really have to look at that whole field of vision to understand where you're going and how you're going to do that. And so I do think, you know, you may find in the U.S. we have this thing called CFIUS, which is really a very dramatic way of dealing with, you know, regulatory and foreign investment. And however you feel about that, it's not going away, and that's also globally moving across the world too. So I think spin-off, you may end up finding spin-offs coming from just a geographic point of view. You know, clearly one thing that we're always tasked with when investing, say, in a European business is how do they get into the U.S.? How do you actually set that up from a regulatory point of view and do everything you're supposed to do? And we've not had any issues right now where we've had to actually take that off and do a completely separate new company. Again, I'm not a lawyer, and I don't ever want to play one either on TV, but it is very difficult to actually do that sort of thing. So, you know, when you look at that, there could be some spin-offs you see of just really arm's length type of companies that are wanting to operate in a certain area because, and they only have to just because of what is happening with world politics and others. So again, I think generally you will continue to watch companies keep their IP, keep all of their, you know, different and interesting businesses that come off of things that they never or any of us expected, that you will keep that, they'll try to keep that underneath their corporate shell, unless, again, from a geographic point of view or regulatory, that they have to take that out.
Thank you. Victor, you've talked about some of the existing and past use cases. Anything you see in the future that could be very exciting?
Yeah, till now, if you see in India, the space program was fully controlled by the government. But now, recently, it has been opened up, and the more and more private players are coming in. Now we have more than 100 plus, around 150 startups which are engaged in the space sector, whether it is launch vehicle development, whether it is space applications, or whether it is satellite building. So as I said, because space technology is basically multidisciplinary with so many stakeholders coming in, building satellites, in building advanced communications, whether it is quantum, optical, laser. So naturally, I think more kind of spin-offs and associated technologies which can find terrestrial applications are bound to come. That's what I feel.
Jonathan, besides what you're doing, I mean, you're obviously in the middle of the space community and you see a lot of things. Is there something else you see that could be a very interesting spin-off or spin-in story?
Yeah, so spin-offs, I can speak about the future lunar economy, given that the Artemis players are going to lay foundations on the moon in the coming decades, and the Chinese are going to do the same around the same time. There are going to be many technologies are going to be needed around this, not only what we're doing. There's a whole value chain, and it's going to relate heavily to the mining industries here on Earth, whether we're talking about prospecting, robotics in general, mining, refining, storage, communication. And this is something that we see beyond what we're doing. Other companies, like Lunar Outpost, for example, that are involved in these future lunar activities and have spin-offs that relate to what we need here on Earth, specifically mining and metals and materials in general, energy as well.
Same question to you, Netta. You obviously have a lot of clients. You already mentioned Dawn as an example. Do you see something on the horizon that you think could be very exciting?
Yes, I have to say that I'm personally very excited about agri-tech. So, as Jonathan said, we're going to, go out of Earth, and people would have to have some plans around, right? They will have to eat, and maybe for mental health as well. So, you see now some startups are starting with these growing technologies in space, which I think is very, very interesting and would be a must at a certain point. And if I would have to bet on maybe another industry which we could have very interested synergy in, that would be food tech for me. I'm still looking forward to seeing where I'm going to see the new startups popping up there, because food is also going to be one of the major things we need to improve when we think about space environment.
Well, I agree. At this point in time, we can give a shout out to a really exciting Israeli startup, Aleph Farms, who is working both on Earth and in space. So I totally agree with you. Baruch, I mean, you guys seem to be thinking a lot about all of this spin-offs and spin-ins at Earth and Beyond. So what is your view? What are you guys really excited about?
So first of all, we are excited about all the verticals that were mentioned. We think that really the space requires significant technologies and it touches everything in life. One domain that wasn't mentioned was data conversion. So we see many sources of different types of data, and we are certain that with the right AI and again cyber, we are going to have convergence of data, and it's going to affect everybody's life, IoT, any application on Earth, and also to enable the deep space journeys. So in general, we are very excited about this new space industry, and we welcome every researcher and entrepreneur to join in and take part of this exciting journey.
Thank you. And as we're closing down here, we have 1 more minute to go. Maybe a personal appeal from myself. For spin-offs and spin-ins to work, we need to build this bridge between what is done in the space sector and then people in the non-space sector who could benefit, either benefit in terms of the spin-off technologies or are very good at something on Earth and can take that to space. But it's really vital to build that bridge. That bridge is all about education. So an appeal to the audience, if you are, well, first of all, if you are here at the Ilan Ramon conference and you are not from space, congratulations for being here and learning about space. That's exactly what we need. If you are from the space sector, I would ask you, please grab your friends who are from other sectors who could benefit from space and talk to them about space and all of the exciting things that space could do for them. And with that, that's the end of this panel. It's actually the end of the Ilan Ramon conference. I would like to thank my panelists. I would like to thank also the Ilan Ramon Foundation for putting on this really fantastic annual event. So, Toda, Lietaot, and please join me in an applause for our panelists.
So thank you for the great panel and for spinning us in and out in all directions. Ladies and gentlemen, it is with great pleasure that we come to the closing of the 18th Ilan Ramon International Space Conference. We have had the privilege of hearing from some of the most renowned experts in the field and have been able to discuss and explore the latest advancements and developments in space technology. We would like to extend our sincere gratitude to all of our speakers and attendees here and online for their invaluable contributions to the success of this conference. We hope that the knowledge and connections gained here while you're drinking coffee and mingling will continue to inspire and propel the space industry forward in the coming years. On behalf of the Israeli Ministry of Innovation, Science and Technology and the Israel Space Agency, I would like to thank you for being part of this conference, and we look forward to seeing you again at the 19th Ilan Ramon International Space Conference next year. Enjoy the rest of the Israeli Space Week and your stay in Israel. Thank you very much. And thank you.